Welcome back, everyone. We are here for day 10 of the completely free Go Cloud Careers Azure Solutions Architect Expert Bootcamp to prepare you for the Azure Solutions Architect Expert exam, otherwise known as AZ 305. So, we've had some fun here for 9 other days. We had a week, the first week, where we talked about the underlying technology and we really got into some strong fundamentals. And truth be told, we probably got deeper into the underlying technology, a lot deeper actually than Azure would actually do on the exam. And the reason I wanted to do that was to level set everybody, make sure they actually understood what we're talking about, and not just, the language or the vocabulary or the marketing speak that's actually in any certification exam. So go back there. And if you've not joined us, if you've not been with us, please watch that first week. And that was our cloud fundamentals training that we did for that program. Now, this week, we've been focusing much more on that official certification material, those type of materials that'll show up on exams, where that was much more focused on things that you actually need to know. So we've done that. I've had lots of fun. Hopefully, you guys have all had a lot of fun. And we're going to continue today. So before we begin, I'll talk about some free things that we always do. There's labs if you're just joining us, and I'd love you to go do them, especially if you've got your goal is a hands-on role, like a cloud engineer or a DevOps engineer, where you're going to be hands-on. We all know we architects don't really touch the technology. We're all about designing systems and optimizing business processes and optimizing business performance and leading large teams of individuals and giving presentations and building business cases and responding to RFIs, RFPs, RFQs, what have you. But you may still want to get hands-on to just see what it feels like, and that's okay too. I love getting hands-on. Anybody that knows me knows that I've got an OpenStack cloud in my house that has about 10 servers that run on it. I've got a collection of firewalls, routers, and switches, because even though in my world I don't get to be hands-on, sometimes I still like to play. I call it fun. So there is that. So make sure you get access to those free labs. In the description of this video, we have a tremendous number of free resources to help you. How to prepare for an interview, for example. Potentially cloud architect interview questions are in a lot of our videos. AI architect interview questions you may find in some of our videos. Preparation, the skills you need to be hired, what kind of certifications boost your career versus the certifications that actually can damage your brand and damage your career. And they're all free in the description of these videos. So we're going to come back to the content today. Tell me where you're at in the chat box before we begin. I know Tom's over there in the Netherlands. I know Leo's out there in Sao Paulo, but where are you? I'm in Port St. Lucie, Florida today. Finally, this massive thunderstorm just ended, and it's nice, bright, and sunny. So let me know where you're actually at, and then we'll begin. And then after you let me know where we're at, give me a hashtag AZ-305. Alpha Zulu 305 for those of you like me that choose precision communications and like to use the phonetic alphabet. And that way we don't have any mistakes. Cantor, so good to see you back today. I see we've got some folks in Nigeria. I love that. And I know you're also, so I see some more AZ305. So, okay, I know you're awake, you're alert. Bonita Springs, Florida. I haven't been there in a little bit, but I'm not that far away since I live in Florida. JFDF Trades in Jamaica. Welcome, welcome, welcome. One of my favorite places in the entire world. Spent a lot of time there. Actually, you know what? Maybe my cat Cindy and I, because my wife's away, we'll have some saltfish and aki tonight. That actually sounds pretty good. I have some aki. And, when there's a Greek expression that says when the cat leaves, the rats dance. It says "Molisi gataki safigi ipodiki horevi." My wife's actually up in Philadelphia with her family members right now, so maybe the cat and I have some cod and aki. She won't like the aki, but she'll definitely like the cod or the saltfish that I would use. So sounds like a great thing. Igor's over there in the UK via Poland. Valerie's over there in Winnipeg. Sounds pretty cold, Valerie, although not this time of year. And Ravi's in Delhi. Love it. Okay, so we will begin now. So where we ended yesterday, we're beginning on some of these introductory level concepts that are in the Azure Solutions Architect Expert exam as it pertains to networking. And we're going to continue that. So we're going to, if we want to connect to our systems on the cloud, we need some form of wide area network to get there. And obviously we can use a private line called an express route. or we can use an IPsec tunnel or a VPN. So we're going to really talk about how to connect your on-premise environment to the cloud. Because if it's internal traffic to your business or important traffic, you don't want it on the public internet if you don't have to. And if you're going to go through the internet, we're going to have to tunnel it in a manner to make sure that it's safe. So in this case, we're going to talk about connecting your network. So there's lots of things we could use. For VPNs, we would use the Azure VPN Gateway. And effectively, the Azure VPN Gateway is a VPN concentrator service for you to attach to. We can use, obviously, Azure Express Route. We can do like we've done in networking for the last 30 years. You've got a primary link and you've got a backup. So we can do a private line like Express Route with a VPN failover. And of course, we can create these hub and spoke networks on the cloud in much the same way we've created hub and spoke networks for the last 40 years in networking. Nothing's really new here. So we'll discuss that Azure VPN Gateway very briefly. And it is like a virtual router that you connect to that will terminate your IPsec connections to Azure. And by doing so, you've got your router and you're connecting to that far end router. And in that first week, we really put that into a whiteboard. We talked about how we were creating those IPsec connections over the internet to provide that information confidentiality, to provide that message integrity, endpoint verification, and of course, non-repudiation. And we talked extensively about what those were in that first week. And we can do that here. So we create a site-to-site VPN, which is basically like taking your New York and your London environment and creating an IPsec tunnel over the internet with a router on both sides. We could create a point-to-site, which is kind of like when you use your PC to VPN into an office, where that's basically one user. We can connect a VNet to a VNet over a VPN. We could do it over VPC peering. So you might be a parts manufacturer, for example, and let's say you're a PC and manufacturer, and you may want to need to get some GPUs from NVIDIA and AMD, and they're both on Azure. So that might be a place where you might do either VNet peering or an IPsec tunnel to the both on the cloud. So what are the components that go into this? Well, you can use the Azure VPN Gateway. It's very simple to configure. It gives you bandwidth of up to 10 gigabits per second. And all you need is a router on your end, and you're connecting it there. Now, normally speaking, we have a router on both sides of this. And you could basically go from the internet into a VPN concentrator that you got from, say, Cisco or Palo Alto or Fortinet on the cloud too. But if you wanted to use Azure to go terminate your VPN traffic, that's what we're actually talking about. Of course, we could also use a private line. And a private line is basically a wire between you and the cloud provider. And because it doesn't go through the internet, its performance is guaranteed. Remember, internet bandwidth is never guaranteed. It is best effort. But a private line, if you've got a 3 millisecond link from point A to point B, it will always be 3 milliseconds. Whereas if the internet gets congested, the latency will go up. The internet can reroute. It can lose your traffic. So kind of keep that in the back of your mind. Now, when we use these environments, for the most part, some of them enable dynamic scaling up to a greater capacity. Some of the providers of our wide area networks do not. Here's the only thing to think about with Express Route. It's going to take some time to set it up, because you've got to call a wide area network provider to basically connect you to an Express Route connection, and then you're going to have to get permission from Azure to go from that customer edge router that's yours in that location to the provider edge router, which is Azure's on that location. And we drew that out extensively in the first week. So go back and look at that to really get some things. So there's some time that's there. But if you've got a hybrid cloud and you need good performance of your systems on the cloud, they're there. If you've got all your systems in your cloud and you need good performance in the cloud, you're still going to use something like a private line or Express Route because you need good performance. The hybrid would basically mean maybe you use a software-defined IPsec tunnel, like an SD-WAN one or a SASE WAN one, and that can get closer to private line performance as opposed to a traditional IPsec VPN, but it's still never going to be the same. Of course, we can do our private line, which is an Express Route connection, and then we can basically use an IPsec tunnel or a VPN for failover. And we would do this because if the primary line fails, guess what? We'll back up to the IPsec tunnel over the internet. Now, not hard to set up, but you're going to need good redundant hardware there. Ideally, one for your IPsec tunnel and an additional router for the one that's providing your WAN network. And just note that when you're in a situation like this where you go a private line to VPN, the VPN may not be enough of a backup. So if that's the case, just do 2 express routes or 2 private lines, and you'll be good to go. And then add a tertiary backup with a VPN, which you can do as well. So we can also do this concept of a hub and spoke network. And a hub and spoke network is where basically you've got a central location and everybody reaches out through them. And we can definitely do that as well. By doing hub and spoke networks, it minimizes the actual overhead that's needed. And if the spokes happen to be on Azure, we don't need to get involved with placing routers at each site. And we can use our direct connections. So let me just show you quickly what that's actually going to look like. For those of you that are not super familiar, and I hope it becomes very obvious for you when we create these hub and spoke connections that there's good and bad. So what we're really talking about here is this is your campus, or where your workers are, but we'll call it campus. And you connect to your cloud provider, and I'm going to call this whole thing the cloud provider. And in this case, let's say this is your main VNet over here. And you may have a couple of other companies that you might deal with, or other partners or other branches of your business. Let's just call it Site 1, Site 2, and then Site 3. And obviously, to make this work, you're going to have to set up transitive routing, or it won't work. But if you want the sites to be able to communicate to each other in a hub and spoke environment, and we talked about how that's done on cloud providers, and IBGP transitive routing is enabled by route reflectors, for example, or else fully meshing your systems. In a cloud provider, you might use Cloud Hub or a transit gateway on AWS to break these rules. We talked about how to do it yesterday on Azure. And realistically, what's going on here is you've got your private line that's going to connect you to your VNet. And through your VNet, you'll be able to reach Site 1, Site 2, and Site 3 that's over here. Obviously, these sites are going to have to provide dynamic routing or routing information to the VNet, or your campus won't know how to reach it. And then Site 1 can reach Site 2 through your VNet. Basically, you've got a virtual router there that's doing things. So that's really all we're really talking about in these hub and spoke environments. See this? That becomes a single point of failure. So generally speaking, if you're going to do a hub and spoke in a high availability environment, you're going to connect to 2 hubs and have 2 sets of spokes. So just keep that in the back of your mind. So think about a VPN gateway as through the internet, best effort traffic that you hope to have. Think about Azure Express Route as a guaranteed performance. Think about Express Route plus VPN failover is you've got something good as a primary, guaranteed, and your backup is best effort or whatever you're going to get. And then Azure WAN, a virtual WAN, is basically creating a hub and spoke network, and it makes it simple if your systems are already on Azure. And if they're not on Azure, maybe don't connect through Azure and connect just through your on-campus location, because here's the reason why. In a normal environment, you buy a connection to a provider. Let's say it's a private line. You pay for the private line. But when it comes to connections on the cloud, you pay for the lines. Typically speaking, you pay for usage. You pay for all these interdepartmental regions. And while it's simpler on the cloud, it may cost more. So you may actually want to create these WANs off the cloud. But you won't know that until you understand your traffic patterns and the performance that you need and the sophistication level of the people that you have on your team. Pretty easy for me or Mark Leovanovich to do this off the cloud. In fact, it's going to be 10 times easier for us to do it off of the cloud. But if you don't have really good, strong networking people, and if you don't have good networking people on your team, your systems will come to a collapse anyway. But if you don't have good, strong networking people on your team, these cloud type WANs become very simple and elegant. So we're going to talk about a little bit about an application delivery services, specifically related to load balancing services to distribute your workloads across multiple resources. So there's lots of opportunities we ultimately have. So there's various forms of Azure load balancing things that we can do. We can do global load balancing. We can do regional load balancing, for example. And so we need to think about what we're doing. If we're dealing with HTTP or HTTPS traffic in a public environment, we'll typically speaking have a load balancer directly in front of our virtual machines. But we may want to also load balance across the Azure Virtual Network or across regions. And that's going to be done slightly different. If we load balance across regions, typically speaking, it will improve our availability than if it's just in one availability zone or our multiple availability zones. Because if a region goes down, you've got nothing. Now, we really want to think about, do we really want to load balance for two reasons? If it's from a high availability perspective, it's ridiculous, load balance between two clouds. If we're doing it because we've got customers in both regions, then load balancing makes sense. So there's lots of reasons. It's the rationale behind the decisions that you're making that actually matters. So let's talk about the first, global load balancing type service, and that's going to be Azure Front Door. And this is for HTTP load balancing or HTTPS load balancing. And basically speaking, we're going to get some SSL termination on this type of a load balancer. We can route based upon URL or session affinity. So we can get fairly granular over here. And this is going to be perfect for an application that's going to need global load balancing. We also have access to the Azure Traffic Manager. And this is another global load balancer that's going to distribute traffic across regions. But this will also work with non-HTTP or non-HTTPS traffic. So it's really going to be a DNS-based load balancing, and it's going to function based on DNS addresses. So we could use this for potentially disaster recovery. We can realistically use this for geofencing scenarios, but that's more of what we're talking about. And ideally, we think about it, if we're going to deal with multiple clouds, we can't use something like an Azure Traffic Manager for this. And here's the reason why. If Azure goes down, we've got nothing if we're in 2 or 3 clouds. But F5 makes some really good DNS products that we can use for something like this to load balance commercially, where you can put one of these virtual machines in all your clouds. Organizations that are really good with Linux can set up a bind server, Linux DNS to kind of do these things. So it's no big deal, but this is the Azure pre-made service. Now let's talk about inside of our systems. Well, here we've got the Azure Load Balancer, and this, realistically speaking, is a traditional software-based load balancer that you would have. Very similar to a Google Cloud Load Balancer or an AWS, what they have to call theirs Elastic Load Balancer, but it's the same thing. It'll work with TCP and UDP traffic, and it's going to give you good high-speed performance because effectively it functions like a network load balancer. And by doing so, it's going to look at the source, destination, protocol, port number, and it's going to be really, really fast. Network load balancers are really fast. So you could use it internally to load balance between some private, say, finance servers that you don't want on the internet. You can use it any way you actually need. And that brings us into the Azure Application Gateway, which again is going to be a way for us to balance traffic, say, inside of a region. And when we're dealing with something like this, this is much more of an application load balancer. So it's going to look at HTTP, at HTTPS kind of traffic. It's going to be able to look fairly deeply into what's going on in HTTP or HTTPS. So it's not just TCP protocol, TCP, UDP, source address, destination address, and port number. No. Now we can start looking into the headers. Is it an HTTPS push, get, that kind of thing? So much more intelligence. So as we get into application load balancers and we get more intelligence, our performance goes down. So network load balancer is fast, application load balancer is slow. Application load balancer is smart, network load balancer is dumb. So what do you really need to use? So what are some things that you need to consider when you choose load balancer? Well, first, your traffic type. That's one of these things that you try to need to do. Are you load balancing virtual machines? Well, then you use an Azure load balancer or an Azure application gateway. Are you load balancing globally? Is it HTTPS traffic? Realistically speaking, where you're going to use Azure Front Door, or is it going to be just based upon DNS where you're going to use Azure Traffic Manager? So there's that. And that's really what we need to think about when we set these things up. We need to look at what we have. We need to look at the cost options for what we have, and we need to look at the performance option. Let's talk briefly about designing for application delivery services. So, Azure provides some networking services to deliver your applications efficiently to help provide high performance, low latency, and scalability. And we've got some services here that we'll talk about. So, one is that it's a global solution. With application delivery services, we can cache. And basically speaking, we're caching content based upon the way I showed the content delivery networks work in the first week, where we talked about cache hits and we showed cache meshes and we showed the way these content delivery networks work. Now, we've got lots of caches that you could potentially use and lots of content delivery networks you would use. Microsoft has theirs. Akamai has an incredibly good one. Verizon's got a content delivery network. Here's the thing. A single content delivery network is a single point of failure. And that's why, even though that Amazon has their own CloudFront, if you were to do an NS lookup of Amazon.com, what you'll see is that sometimes you're going to hit the CloudFront content delivery network, sometimes you're going to hit the Akamai content delivery network, and sometimes you'll hit the Fastly content delivery network, and other ones may be used as well. Because Amazon's not crazy enough to use only a single content delivery network for enterprise applications like theirs. And you shouldn't be either when you deal with a company that needs big business and high availability. Now, if downtime doesn't matter, use a single content delivery network. But if downtime matters and has a big cost, that will become a single point of failure. So keep that in the back of your mind. And by using these internet-based point of presences and by putting caching servers on these internet-based point of presences, we can reduce latency, we can reduce delay, we can reduce router hops and improve the performance of our client application. So we'll briefly talk about Azure Front Door now, and that's going to be for global routing management. And this is going to give us the ability to define, manage, and monitor our global traffic. We can optimize our performance and our latency with global failover, and it gives us the ability to route support for primary and secondary backends, weighted distributions, and Infinity. And in that first week, we talked about various routing types, where we talked about maybe we were deploying a new application, and you send 10% to the new load balancer of the new application, 90% to the old one. If everything works good on the new application, use DNS and shift everything to the new one. We use that kind of an example. Or we could send 50% to AWS and 50% to Azure in a high availability environment. These are the kind of things that we're talking about. And you can actually put like the cloud provider's web application firewalls on what we're dealing with here. And you might add it to like a solution like Azure Front Door, but don't think any of these cloud provider firewalls are going to give you enterprise grade security. You're going to need a next generation firewall. And this is across all cloud providers. Their business isn't making firewalls. It's basically in creating hosted data centers. So I'm going to discuss a little more about Azure Traffic Manager because we introduced them before. And this is about distribution across global Azure regions for the most part. And this gives us much more routing abilities. We can do priority routing. Priority routing would be route to your OpenStack cloud, which is 100% paid for, and it doesn't cost you anything to use. And send some, and then if anything happens, send it to Azure. Weighted is send half to Azure, half to your OpenStack cloud. Performance might be send it to the lowest latency. Geographic is going to be based upon where you're at. So subnet routing, send it to this particular subnet. Multi-value is like a little random. Send your traffic any one of the endpoints that you have. So now let's discuss that Azure Load Balancer again. This is a network load balancer, so high performance, low latency. It's going to look at the TCP protocol. So source IP address is X. The protocol is TCP. The destination is 1.2.3.4 on port 443. That's the kind of thing that we're actually talking about, layer 4 load balancer. And with Azure Load Balancer, we can configure them for internal, like I said, internal systems that you don't want on the internet. They're called internal load balancers. You can set them up for external load balancers, which means publicly facing, which means on the internet. And we talked about how all these load balancers improve performance and availability in the first week when we talked about running health checks. So if you're not familiar with that, please go back to that first week. We got pretty detailed in it. Now we're focusing more on that certification, which is a lot less knowledge on how the systems work. But a certification will get you an interview. Knowledge and capabilities will get you hired. So that's why we try to give you a little of both here. First week, we focused on what matters. Second week, we focused on the certification. So keep that in the back of your mind. That's what we're dealing with, that Azure load balancer. And again, this Azure Application Gateway is an application load balancer with a fancy name. And that means it's going to look at everything in the HTTPS or HTTP header, the method of routing, everything. So much more intelligent. These are much better for routing between, say, microservices because they're smarter. But as you do things smarter, you slow down. How fast can you add 2, 4, 6, 8, 10, 12, 14, 16, 18, 12? You get the concept. It's like a network load balancer. No. How fast can you calculate a derivative in your head? Now, my wife can do these things instantaneously because she's a math genius. But for the rest of us normal humans, we're not going to calculate a derivative in our head. We're either going to use spreadsheets or we're going to write it down on a piece of paper and we're going to have to think about it. And that's the key here. When we're dealing with application load balancers, they're smart. They're doing complex work, and it's done. Complex work is designing an architecture. It takes 15 to 50 people, 6 to 12 months to figure out everything that's going on before you can design it. That's complex work, which is the exact opposite of how you turn on a virtual machine. Click, click, clear, and it's done. One requires a lot of planning. One requires basically nothing. It's very simple and easy to do. So let's talk about application protection services. So Azure provides some networking services to help protect your resources. So one of it is Azure DDoS protection. So the point of this is to help deal with sophisticated distributed denial of service attacks. And on that first week, we drew a visual where we actually showed you what a denial of service attack was, and then we drew out what a distributed denial of service attack is. And all the cloud providers have their DDoS protection. And what's really going on is they're constantly monitoring your traffic. They're looking at your traffic and they're trying to mitigate it. They provide a bunch of different levels of attack analysis and metrics. So they look for things that are uncommon. If I see a lot of like a SYN flood attack where thousands of SYN messages are coming in to open up ports on the web server, and there's nothing more than just SYNs, it'll close it down, potentially can an ACL on demand, that kind of thing. If we're seeing like a ping of death come in, block those pings of death. If we're seeing illegitimate traffic coming in, block it so it doesn't hit the server so it can't do damage. And that's what we're typically talking about, these DDoS protection services. And these DDoS protection services are wonderful, but they're not going to be enough by their own. It's going to work with that defense in depth typology where it's like an onion. We're sure we've got our DDoS protection on our content delivery network, and then we've got a set of next generation firewalls. And maybe we've got a set of IDS, IPS systems, even though that's integrated into the next generation firewalls. And then we're going to have some network security groups, and we're going to do so many things along the way. It's not going to be enough just to use DDoS protection services. So keep that in the back of your mind. It's part of the solution. Kind of like a diabetic might take insulin as part of their solution, but they're going to have to change their diet. They may have to exercise. It's just one component of the whole package. Now, we talked about it a lot in the first week, so I'll just graze over private link. A private link is basically a virtual tunnel that's being created, a virtual wire on the Amazon network. And generally speaking, it's there to provide secure access over a private endpoint. So inside of your network or your VPC or your VNet, you've got your own systems. That's in your virtual private data center. But if you're going to connect to an Azure SQL database and it's not in your VNet running on a virtual machine that you set up yourself, you're going to have to connect to an endpoint to get to it on these managed things. And that's what that's typically used. Basically, what happens is it creates this virtual tunnel or an overlay network. Maybe one day me and Mark Milovanovic will actually create some overlay networks over an IP network and do it on some routers so you can truly understand it. And I'll probably do that for fun. I think you guys would like that someday on YouTube. But that's really what we're talking about. Now, the next application protective service we have is the Azure Firewall. This is a managed cloud-based firewall for your Azure virtual resources. It's stateful, like all firewalls are. You can use a public IP address on the outside. It provides protection for non-HTTPS type protocols, but here's the thing. It doesn't come close to a next generation firewall that can look for patterns of behavior that are anomalies and stop it. They're based on AI. So if it doesn't matter, you can use these kinds of cloud provider based firewalls. For my website on MyCat Cindy, yeah, I'm going to use a WAF. I'm going to use one of these Azure firewalls. But if it really matters, I'm going to call up Cisco, Palo Alto, Checkpoint, Fortinet, and I'm going to get a next generation firewall with anomaly detection. Same thing to go that we're actually talking about over here, where we're talking about Azure Web Application Firewall. Again, it's something to protect your web applications. It's easy, it's pre-made. It gives you out-of-the-box protection for the top 10 vulnerabilities. You can create some custom rules based on source IP, and it gives you centralized management. And you can react a little faster to security threats by patching known vulnerabilities. But that's the problem. It helps you with known vulnerabilities. The better industrial enterprise-grade next-generation firewalls that I'll talk will get you to unknown vulnerabilities. And here's the thing. It's like a boxer. If I only know how to block a hook punch, that's great. But what if somebody comes in with an uppercut that I'm not planning, or they hit me with an elbow when I'm not planning? Well, I get hit. And that's what happens when you use things that only protect you against known attacks. You get hit, you get attacked, and it's not a great situation. So keep that about. Part of your solution involves keeping unwanted traffic out of your systems, out of your virtual machines, out of your subnets. And that's why on our normal networks, we use ACLs to protect each subnet, in addition to many other things that we can do on our network. We can't do those things here, but we can still do an ACL. What's an ACL do? This application server can talk to this database, but nobody else can. That'll further enhance the security inside of your systems. Now, remember, databases are network access lists, or any kind of network security group, typically speaking, needs to be applied inbound and outbound if they are not stateful. That's why access lists apply both in one direction, or that's why firewalls, you only need to apply the rules in one direction because they're stateful. If your traffic goes out to the internet, you'll recall when I drew it in the first week, it shows you your traffic patterns. It builds a table in the firewall, and it lets you return traffic in, but it blocks all other external traffic. Keep this in the back of your mind. But ACLs and network security groups, they are awesome for enhancing your security, so keep that in the back of your mind. Talked a little bit about endpoints, but we've got the concept of service endpoints. And realistically speaking, by doing so, you can extend your virtual network private address space to Azure services over your direct connections. So you can basically reach these typical things that you might actually have from your direct connection into the cloud, because you put an endpoint on them, and you're basically in the endpoint will put a route. You'll have a route on the routing table to the endpoint, and your on-premises systems could attach it, for example. So securely connect to Azure resources. Now, Azure Bastion. So generally speaking, a Bastion host is one of the biggest security risks you could ever imagine, because typically in a Bastion host, and Chris, you can provide a video that I put a link to the video why Bastion hosts are traditionally dangerous, because that's why you have Billy Bob sticking out a virtual machine in the middle of the internet, who's not an expert at locking down virtual machines, and it's basically one network into the internet and a backdoor into your network, avoiding all your good firewalls, all your IDS, all your ACLs. Is typically a disastrous situation. And that's why you typically use a VPN concentrator to attach. Now, the Azure Bastion is the exact opposite. This is a good situation. Azure Bastion is basically a pre-made virtual, VPN concentrator from Azure, where Azure locked it down, set it up properly where you can use it to connect to your internal systems. So the Azure Bastion host does not apply to the why Bastion hosts are terrible. This is a pre-made by the cloud provider. They've invested all the money that's necessary to lock these systems down, harden these systems, test these systems, and this is not a dangerous backdoor. This is totally fine. And because it's going to be secure remote connections, if you were to use SSH inside of this or RDP inside of this, it's integrated with Azure Firewall. So it's a reasonable remote access solution that you could use for your cloud. Another thing we can talk about is just-in-time network access. The goal here is to lock down our inbound traffic to our virtual machines, but be able to add access to it when we need it. So this feature is basically going to block inbound traffic to whatever ports we tell it. And it's going to be just like a firewall where it denies all inbound traffic except for what you approved. But it will also temporarily allow inbound traffic if access is needed. So the business scenario is to reduce your exposure to attacks by still giving you access when you need it. And this way we can ensure the secure and monitored access to virtual machines when they're needed. So we need to think about when and where we would use this cloud adoption framework. The Microsoft Cloud Adoption Framework for Azure provides a structured approach to adopting Azure to your organization, which is great. The problem is, most technology projects fail. This is the problem with the Azure well-architected framework. This is the problem with the AWS well-architected framework. All they think about is tech. They're all about the tech. Although the Azure one is a little bit more business in it than the tech. It's much better than just the AWS one, which was all about the tech and none about the business. We have to remember that if the tech doesn't support the business and the tech doesn't get the business to its goals, it's like you going out there and spending $1 million on a Ferrari that never shows up in your house that you can't drive. Yeah, that's no good, right? So spending money without getting a business benefit is a waste of time. And if we only focus on these adoption frameworks, we're not getting to our goals. So they are tools. So there's some great things about the cloud adoption framework. It gives you the ability to think about your cloud adoption goals and strategy. Well, I hope before you thought about spending any money, you thought about your business goals, business pain points, and business challenges. It can help an organization prepare for a cloud migration by theoretically assigning teams and roles. Theoretically. It can help with migration and modernization by helping an organization migrate existing workloads to new cloud native or hybrid solutions. Well, again, maybe cloud native is right. Maybe cloud native is wrong. And we're dealing with frameworks that are designed to get you to spend more money, to get you to adopt things, whether it's in your best interest or not. All these cloud providers are doing this. So generally speaking, you have to take it from their way. Their goal is to get everybody to the cloud. They should. That's their business. Your goal as an architect is to evaluate, is the decision to go to the cloud the right one? Should this application be on the cloud or should this one be in the data center? Should this one be microservices based or monolith based? And the second we have a preference, that's when we start hurting our customers. We are trusted advisors, and you can't be trusted by having a bias towards anything. Keep this in the back of your mind. And these cloud adoption framework has some good governance ideas in there. But, it doesn't evaluate the organizations. It doesn't evaluate its people. It doesn't evaluate its processes. It does none of that. So when we use these cloud adoption frameworks, when we use these well-architected frameworks, make sure that they're only part of what we do. Maybe use, say, a TOGAF 10 framework to focus on all the digital transformation you do. And then when it comes to just the Azure stuff or just the AWS stuff, then use that well-architected framework, but not as the predominance of what you're building your systems. So, basically speaking, what they're talking about in the cloud adoption framework is to design your strategy, plan what you're going to do, assess your readiness, then start adopting the situations, securing your systems, managing them, and then governing them. So there's a lot that goes into it, and some of it's really good. But kind of keep that in the back of your mind. I'm going to go a little longer, but I'm going to finish some more on this topic, and then we'll take a break in about 5 to 10 minutes. So we have to think about the migration approach. So the first thing anything comes is always an assessment. And, a normal assessment in an architecture is going to take 6 months to understand all the organization's technology, all the organization's processes, and sometimes it takes 12 months. And it's not going to be one person. It's going to be 15 to 50 people. And that's why we architects aren't allowed to touch the tech in real architecture jobs, because we're leading these teams. We have to understand the tech, understand the business processes, understand the goals, understand the cost of what we have. We need to understand the cost of upgrading it in the data center or keeping it in the data center as is. Evaluate all costs of going with the cloud, all the cost of migration, all the people that are necessary, any cost of refactoring if we choose to do that. At the same time, we're going to identify opportunities for improvement. Maybe modernization is improvement. There's a lot of businesses that could leave the cloud and go back to a mainframe and be better off too. And that's why mainframe spending is going up. And that's why you see organizations going to the cloud, organizations leaving the cloud. And that's why we're never going to get rid of the data center. And it's probably why the mainframe will not go away too. And so after we assess, what we really need to do next is plan. But according to these frameworks, now let's deploy. So we're going to implement that migration plan. We'll set up the infrastructure to kind of be as good or close to as good as we can to what we used to have in the data center. We use the tools to make a smooth transition to the cloud. We ensure that the workloads are optimized and they work well in the cloud. And you can see when organizations don't do this all the time, their performance becomes a nightmare. But if they do this and they assess it and they know what to move versus what not to move, now you've got some magic. And at some point, you need to release it. And basically, you're going to test, optimize, and document your workloads before you release them to users. So hopefully, there's some comprehensive testing. Then we optimize our workloads and look at it, and it's there. But okay, this isn't performing well, so we fix this. This isn't scaling, we fix this. We document everything we've done. We document the configuration that those engineers did. We document any changes made. We create what's called an as-built diagram, which shows the way it was actually built versus the way it was designed. And then we hand the workload over to the end users for production use and make sure that we've secured it. So that's kind of really what we're doing. So I will go take some questions now. And then after the questions, I'll come back and we'll keep talking about Azure stuff. What's the difference between RAID 0, RAID 1, RAID 10, and disaster recovery? So none of these things are related. So disaster recovery is what happens if a major disaster were to hit a business. An earthquake, war, a massive flood coming in, shutting down a guard region of the company where the business is at. That's disaster recovery. RAID is really about redundant array of inexpensive disks, and it's designed to improve speed and it's designed to improve performance. So realistically speaking, and we actually did a fair amount of this on the first week, RAID 0 is this. RAID 0 is I have one hard drive that's say 2 terabytes. I have another hard drive that's 2 terabytes. I have another hard drive that's 2 terabytes. This drive gives me 500 megabit a second. This drive gives me 500 megabit a second. This drive gives me 500 megabit a second. And we just put data, we share the data on drive 1, drive 2, and drive 3. So if we've got 3 drives that are each 2 terabytes in RAID 0, our total capacity is 6 terabytes. If we have 3 drives that are 500 megabit a second, and we share the load across all 3, effectively we're getting 1500 megabit a second. Now, RAID 1 is the exact opposite. Here we've got 2 drives that are basically each 500 megabit a second. Everything that's written to this drive gets copied to this drive. So if I put a picture of my cat Cindy on this drive gets a picture of my cat Cindy. So basically what happens is if this drive were to fail, we just basically use this drive. So RAID 1 gives us total redundancy, but no improvements in speed and no improvements in capacity. So if I have 2 terabyte drives in RAID 1, I have a total of 2 terabytes of capacity, and my speed is 500 megabit a second. So that's RAID 2, or RAID 1. RAID 10, by comparison, is basically a combination of RAID 1 plus 0. So if I have one RAID array that's each got 2 terabyte drives that are basically 500 megabyte per second each, I've got 1500 megabit per second, approximately, a little less because there's latency involved, and 6 terabytes. And in RAID 10, what I do is if this is my primary RAID 0, I build a backup. And anytime I write to this tray, I copy everything over here. So if any one of these components in this drive were to fail, everything goes over to the backup RAID array. That's RAID 10. But disaster recovery has absolutely nothing to do with this. It's more related to business planning, what happens during a major disaster. And if you go to the video last week, there's a lot of depth here on it. Can I please review DNS resolution for on-premise domain names within a subnet and a VNet? So it's the same thing. All DNS is the policies that we talked about in that first week. If we're doing something simple like a DNS-A record, and the address of 192.168.1.1 is the equivalent to www.sandythecat.com, you can resolve that in your data center. And obviously I used a private address, but it would be public, and it would do the same thing in the cloud. There's nothing different. It's the same DNS that's 40 some years old. Nothing different. Chris, we can go to the next one. You mentioned SSL termination in Azure Frontier. VPN tunnels can use IPsec and SSL or IPsec only. So, Kenner, we have two kinds of VPNs. In reality, we should be using IPsec. There was a period of time where we used these SSL VPNs because of their convenience, but here's the reason why we typically don't use them. With IPsec, we basically encapsulate the entire packet, the header and the payload, into this IPsec tunnel. And why do we do that? If we encapsulate the header and the payload, all the traffic on the wire is encrypted, which means you don't know who I'm sending traffic to or what I'm sending. When we use SSL-based encryption, which is really TLS encryption because SSL went out about 10 years ago because it wasn't secure enough and TLS replaced it, we don't, basically speaking, encrypt the header. We only encrypt the payload. So let's say I was speaking with Cantor. You'll still know that I'm speaking with you. You just won't be able to see what it is. Now, from a security perspective, do I want anybody to know that you and I are speaking? No. So that's why, we could use it for a VPN, but if your security matters, you probably should not use SSL-based VPNs. Why were we using SSL-based VPNs for a while and these TLS-based VPNs? Well, typically speaking, for IPsec, we used to have to put a client on the website. We'd have to set up a pre-shared key, and it took a few minutes to actually do it. Where with an SSL or a TLS-based VPN, you could just do it over a web browser. But which matters more, the inconvenience of installing a client? In most cases, the clients are now embedded into our operating systems, or security. So hope that makes sense. Good question there. In a failover situation, when the second kicks in because the first one failed, what happens when the first comes back on? Depends on your routing policy. So, did you set your routing policy where one link is primary and the other link is secondary? So basically speaking, if you're using BGP, if one of the links, if the top link, let's say your top link is primary and your bottom one is backup, and you have an aggregate or summary route on the backup, and you have more specific subnet links in your BGP routing table on the top link, if the top link is up, the top link will be preferred because routers always prefer more specific subnets than the aggregate route or summary route on the bottom. But of course, it's BGP, so you could basically change the weight of the local preference of certain routes on the top link and lower the weight or the local preference on the bottom link to manipulate outbound traffic if you wanted to. You could prepend AASs, you could change the origin code, you can change the meds. So Freedom Lens, I'll have Chris deliver the link for the BGP webshop that Mark and I just did. It was almost 7 hours, and we showed about how BGP works and how this traffic prioritization would work and how you would actually set that up to do that. But that's going to be based upon the way you set it up. Is it active passive? Is it active active? Did you set it up to load share? That's going to be on you. Do bastion hosts expose a public IP address, which can be considered insecure? Yeah, but it's worse than that. The problem is you're You're not creating an intelligent remote access environment. So Azure Bastion is different. It's not going to expose any virtual machines you have. It's going to act like a VPN concentrator. So it's very different than what you're talking about. So, you know, the amount of time it would teach you how to set up secure remote access would probably take us the rest of the day. So I can't fit this in there. That's some place where you're going to need to learn architecture, and it's going to be pretty detailed. How do you set up secure access? What type of demilitarized zones do you need to use? What kind of policies? And honestly, that's not a 2-hour thing. That's more like a 25 or a 40-hour thing to actually make it great, to really teach you. But there's that video that Chris popped up, which showed why the Bastion host, the traditional kind, is such a dangerous thing. I remember doing it at a company 20 some years ago, me and another person, and they were like, Mike, I see what you did. You actually set it up in a secure way. Do it again, and you'll be escorted out of the room by security. Any business that knows better knows why a Bastion host is a terrible idea. But there's a video which we talked about why to do it, which is the exact opposite of how you would set up secure remote access. It's actually in these certification trainings. It used to be. And the reason it was is they thought, well, you would have two things. You'd either have to teach people how to set up secure remote access, and that would take far longer to teach that than it would take to teach somebody how to do an AWS Solutions Architect Professional. So it used to be there. Here's how you set up your backdoor into your systems. So there was that. And then and AWS realized how bad it was, and too many people set it up wrong. So now they added a feature so you shouldn't create a Bastion host. Anyway, Microsoft was the leader here, and they said, look, here's a secure way to remote access if you don't have the sophistication or the knowledge to do it the right way. And Azure did a good job here. It's not the problem that it exposes the public IP address. That's not the issue. The issue is you're sticking a standard computer in the middle of the internet without a firewall with a backdoor into your systems. So think about that. And then think about why that's so bad. Does Azure use RAID 5? So you actually have to determine what kind of RAID 5 and where. So in the Azure system and the Azure network, which you have no access to, yeah, they're using some RAID 5, RAID 6, RAID 50, RAID 60. Of course they are, as is every other business in the world. But why don't they let you use it? So here's the thing. Cloud storage is horribly, horribly slow. I can go right now and get a 19 million IOPS RAID card for a server. Pop that in my server, have it in my data center. Or what did we see was the fastest block storage we can get? 160,000 IOPS was the fastest you can get on Azure. So multiply that 160 times 6, that gets us to 1 million, and then multiply that not by 19. So I can get storage, realistically speaking, that is about 80 times faster in my data center than the cloud. And by doing that, there's that. So because cloud storage is so slow, and because RAID 5 involves writing parity or redundancy data, like I talked about in the first week, the cloud providers don't let you do it because you can't get any slower than they already have. The performance is already bad. You don't want to make it worse. Good question there. But underneath the hood for their RAID arrays, yeah, they're going to use some form of RAID 5, RAID 6, RAID 50, RAID 60. And the only difference between RAID 5 and RAID 6 is 2 backup drives versus 1. Next one's going to be the last one. You're curious about the idea of an internal network versus the cloud. Is there a special architecture process? So businesses will have intranets and they will have extranets. The internet, which is going to be the majority of their systems, is everything that's not on the public internet. And that's going to be inside of their actual network. And the internet is going to be anything that's reachable over the public network. So there's going to be separate networks. Generally speaking, things that will be reachable from the internet will be outside your public network in something called the demilitarized zone. And everything in your network will be behind all these firewalls. It will not be exposed to the internet. And the only internet access that you would typically have in the internet would be the ability to go out to the internet and your traffic come back, but none of your systems will be reachable from the internet. So it's firewalled off internet access. And regarding Robbie's questions, how could you actually estimate the infrastructure? Well, that's going to take you analyzing every single thing. And it's going to take a team of 15 to 50 people. They're going to have to look at every weakness in the chain and look at mean time between failures and actually look at failure rates and look at the policies, the procedures, the change management. And that's why very few people, I mean, I've done a lot of 5.9s availability network, but most people will never get to 5.9s because 99.999% of the time is 5 minutes and 15 seconds of downtime per year. And to do that, you need really great network architects and really other great companies. And no, John, companies are not moving out of the networking business whatsoever. If they everything needs a network, the cloud providers need a network. If you don't have a network, nothing works. We're seeing cloud repatriation, which is actually increasing networking spending. So nobody's moving out of the network. You have no network, you have no cloud, you have no data center, you've got no internet, you've got no nothing. And all a reverse proxy is it's a network load balancer with caching. Still doing networking. It's not doing any kind of anything else like that. But we have to get back to the content. And where did that go? Bear with me. Oh, here we go. So we'll talk about the Azure migration framework. Again, this is not going to be, the kind of analysis that a real business is going to do. This is something for a certification, and we're here to prepare for a certification exam. And reality versus certifications are like a little kitten and a lion. They're both cats, but one weighs 600 pounds and one weighs 7 pounds. One needs 100 kilometers each day to roam around. The other one hangs out in your backyard, that kind of thing. But we have to do this. So regarding the Azure migration framework, stage 1 is assessing your on-premise environment. And the goal is to figure out what you're actually spending there. And hopefully you'll figure out what you can do in the cloud. And by doing so, you're going to look at your tools and your services, and you're going to select the right services for assessment and your migration, your optimization and monitoring. And then you're going to determine your migration strategy. Should you rehost it? Basically just move it. Should you refactor it? Which is basically you take what you have and you tinker with it a little way along the line. And maybe you go from your main great database that you're using and you've been using like your Oracle database, and then you'd go to a managed database on the cloud. Of course, your Oracle database will work in all 3 clouds. So, that's the refactor kind of thing. The re-architect is basically you take what you have and you re-architect it for the cloud. Maybe you've got a monolithic application and you break it down into microservices. And if what you have is an application that's got a whole bunch of redundancy in terms of the services they use and uneven distribution of the systems you use, and you've got 10,000 developers that need to release applications faster, you do that. But maybe your application doesn't have any pattern reuse. Maybe all the services are used there, and going from a monolith to a microservices will enhance your complexity, it'll enhance your cost, and it won't help in any way. So the re-architect has to be done with careful planning. And sometimes this is the greatest thing that you need to do. And sometimes this is the most dangerous and worst thing you can do. And that's why Amazon, tried to make that silly microservice, serverless-based environment for Amazon Prime. And then they realized it was the worst idea they ever had and brought it back to a monolith. So you can re-architect forward and you can re-architect backwards. If your plan's good, you're not going to have to re-architect backwards because you're only going to re-architect what you should re-architect. Now, the next strategy they have is rebuild. And that's basically take the applications you have and rebuild them for Azure Cloud. And that uses all the Azure Cloud native tools and Azure AI and Azure SQL Managers and Azure Cosmos DB. And you do that. And it's all in these managed services. And that may make life a lot easier because you lost all control. Maybe that's the goal. Maybe you want to minimize IT staff, and it's great. But you lose control. Maybe you need control and this is the worst opportunity for you. So that's why you've got to think about which one of these approaches you use. The last approach is replace. And that's basically where you use a software as a service solution. You basically remove certain workloads from your migration and you use the SaaS applications. And again, there's a time and a place. We use certain SaaS applications. We run other things customized too, because you can't just pick a favorite technology. It's like a doctor with a favorite drug. Here, you get the blue pill. You get the blue pill. Why am I getting a blue pill? You got a blue pill because somebody said it was good. You got a blue pill. That's ridiculous. So make sure when you think about these things, you're not doing that. So now we got to migrate the workloads. So we have to figure out what our infrastructure targets are. Where are we going from? Are we going from a virtual machine to a virtual machine? Copy it straight over. Or are we going to go out of the great database that we have and move it to a more managed database? Maybe we use the Azure Database Migration Service. Maybe we're going to try moving a non-critical app to the cloud and see how it works. And if that works great and the business is getting benefits, now we start migrating more workloads. Maybe we put stuff on the cloud and we decommission the systems we have in the data center. Maybe we don't decommission the systems we have in the data center. Maybe we've moved half of our workload to the cloud. And then we take that whole data center that we have and say, poof, we're going to erase it all. We're going to put OpenStack or Nutanix on it. And then we're going to have a cloud here and a cloud there, and we can load share across clouds. We can get a little benefit for the systems we already paid for. They're already paid for, not going to cost much to run them by comparison to running them in the cloud. So this is kind of the things we're talking about that are there. Now, obviously, we want to analyze migration cost. They'll tell you to use the Microsoft Cost Management tool and the Azure portal for cost analysis. Make sure that the people that are calculating migrations actually have MBA level knowledge, whether they have an MBA or not, and they can actually understand how to truly calculate the costs and build an actual business case and look at all factors. Make sure they do, because if they don't, you don't want to be the person that said this is going to save you money and found out it cost 3 times more. That will be the end of your job and the end of your reputation in the industry. So you don't want to do this. We have to really calculate it. So make sure you and the architecture team have the right people with the right business acumen. Because if you use tools like Azure Advisor, it's going to make recommendations. And, these are good tools. I don't want you to think they're bad tools. But if there was a company that was selling shoes, do you want them making recommendations on the fact that you need 150 pairs of shoes? Or would you evaluate, what do you do? Okay, you run, you need running shoes. Okay, you hike in the mountains, you need a good set of hiking boots. Okay, you work in construction, you need steel-toed shoes to protect your toes. That's where you're getting it. You've really got to analyze it. So identify this. And the next thing when you go to the cloud is look for areas of performance improvement. If you can get that, some things might perform better. Maybe your data center is old and dilapidated and it's got a poor network and it's slow. And the next phase is monitor your workloads. So you put your systems over here. We have to capture the health of our systems. We can use things like Azure Monitor logs on target virtual machines. We can set up our alerts. And then we should set up alerts. So if your CPU performance hits a certain amount and it's always there, maybe we need a different level of performance. Look for log files, look for health metrics, find out what's going on with your auto scaling, because if you're constantly scaling out 15 additional servers and you're paying for them as that's auto on demand kind of thing, reserve them and that way it'll cost less. So here is a list that Alonzo made for you on various tools. And Service Map will basically map your communication between applications to a degree. The Azure TCO, Total Cost of Operations calculator, will calculate what it presumes is cost savings. David Lithicum's numbers are great, that on average it costs 250% more to move your systems to the cloud than they are in the data center. So don't expect to actually get any savings here, but you are going to get agility or the ability to change directions easily, add capacity when needed, go from something that you have to something different very fast. And that agility might be worth paying 200, 300% more, because agility can be incredible from a business perspective. So if your total cost of ownership is more on the cloud, expect that. Don't expect savings, but it's okay if it gets you there and it gives you a better business initiative. Tools like Azure Migrate can help migrating your virtual machines and your servers. The data migration assistant can look at your data and detect compatibility issues and help you with that. Your database migration service is basically going to take you from a database, maybe modify the schema and the structure to go into a new database. Microsoft Cost Management is going to give you some things to kind of look at along the way, give you little bits of guidance. Anytime you're dealing with Advisor, all the cloud providers have it. It's just a tech-based advisor. This doesn't come close to humans actually evaluating everything. What they do is they're like, okay, here's our framework, our well-architected framework, and here's your deviations from that. Now, maybe your deviations from the well-architected framework are there. So this is like when a doctor writes a prescription and then they get an automated thing that says, are you sure you want to do this? Because this, and this. And the doctor says yes, because it's the right thing to do. Don't expect that to actually be too accurate, anything in Advisor from any cloud provider, but it's still there. You've got other monitoring tools that can look at what's going on, like Azure Monitor, your logs, your telemetry, your data from various things. It may help you find problems. And you've got that Microsoft Sentinel, which is going to give you some security analytics. This could be something good you might use. You may use commercial SIEM systems to get much better information. But, these are the kind of things that might be there. So if you're going to migrate, well, the first thing we need to do, which is not covered in this, is understand the business rationale, the business goals, the business functions, the business processes. And if you don't do that, you will have a disaster in 7 out of 10 times. But this is a certification, and we don't have the 1,000 hours to teach that like we do in our architecture training programs. So what goes on here? So there are tools to do some automated discovery from Azure to do this. That'll actually look at what you have. And what it'll do is it'll look which servers are talking to which. It'll determine what networking connections are currently working. It'll help you theoretically plan your Azure migrations and theoretically come up with here's how you'll get your business continuity and reliability recovery plans, of course, without analyzing the business in any way, shape, or form. So it's not going to give you anything that's going to be useful for your business people to truly build disaster recovery plans. But it will identify dependencies for patch management, which is great. And that's some of the assessment functions. From a configuration perspective, we can get some log analytics in the Azure portal. There's an Azure Monitor agent that we can put on our Linux and Windows systems to try to figure stuff out. There's a discovery agent we can put on our Windows and Linux systems to try and figure it out. And then, of course, there's that total cost of ownership calculator, which is going to look at your workloads and look at your servers, your databases, your storage. And it's going to give you something, and it's going to give you a little bit of modify the assumptions a little bit, and it's going to make a prediction. So there is that. There's a reason companies have things like FinOps now, because they made all these little assessments. They thought they were going to save money, and their costs went up so much that they need FinOps to actually reverse all these little silly automated tools. So understand that's why, I'm not so fond on saying these tools are going to do it. There's a reason you're going to have lots of business acumen in your architects. Now we can talk a little bit about Azure Migrate. And that has some discovery options as well. It's going to be an agentless discovery that's going to go figure out what you have. It'll give you some information on your virtual machine sizes. It'll estimate your costs for running these systems in Azure. It'll go out there and assess your virtual machines, whether they be VMware-based, Microsoft Hyper-V based, or physical servers. And it will show those dependencies between your virtual machines and groups. Azure Migrate can help with these server assessments because it'll look at what's going on. It'll see what's going on with your virtual machines, how much DRAM is in there, what's going on with your CPU cores, your network adapters, your memory usage, your disk IO, PS, and throughput. And by doing so, it can help you recommend a suitable service on the cloud. You'll also have some tools inside of Azure Migrate Hub. So inside of these tools, you'll have this, I talked about the Azure Migrate that looks at your servers and helps you with that. You'll have your SQL Data Migration Assistant, which will assess your SQL servers and databases for migration. You'll have your database migration services, which will help you convert your databases to whatever the Azure version that you're using, just like AWS has theirs. You may have some web apps that are available on the public internet versus the intranet. It can assess those apps and help you migrate them. And of course, if you've got a lot of data and you've got a high-speed connection to the cloud provider, you send it over the high-speed connection. But if you don't have any capacity and you don't have a high-speed connection, you can use like an Azure Data Box, which is that ruggedized computer we talked about in the first week. And they send it to you, you copy your data to it, and you ship it back. And there's lots of tools to migrate your SAP HANA, your Windows applications, your Java applications, your PHP apps, your Linux workloads. Lots of tools for that. For your web apps, we have the Azure App Migration Assistant that's going to help assess these applications. And it'll determine their suitability for migration. They'll run a readiness check on them. And it will help migrate your apps. And after you migrate, you may consider using a connected database, or you may want to stay on a database that can run in multiple clouds. That's up to you based upon the organization and its business needs. So what are the steps for migrating these virtual machines? Basically speaking, if they are the way they are, you can just copy the virtual machine over in a complete lift and shift. Or you could prepare using the Azure Server Migration tool. That could help you. You could prepare your on-premise virtual machines directly for migration. You replicate those virtual machines and you move them to the cloud, maybe over the network in an image, maybe over a data box if you don't have it. We can briefly talk about the Azure Resource Mover. And that kind of helps you move Azure resources between subscriptions, resource groups, or region. And the key here is it basically is one place that you go to. It makes it simple and fast to move your resources. It'll provide a consistent interface and a procedure for moving different types of resources, which is quite nice. It typically identifies dependencies across resources, but make sure that they are right. They won't always be right. Make sure they are right. It provides automatic cleanup of resources to the source region, and it gives you the ability to test and move your applications. You also have that database migration service. And what is that for? To take your databases and move them to the Azure databases, like Cosmos DB or Azure database for whatever. But before you can do that, realize that 98% of enterprises are multi-cloud, so probably don't use this. We use a more open database that could run there, like Oracle or Microsoft SQL, and run those servers in 3 clouds, for example. Or MySQL or Postgres, and stay on something that you have complete control over in 98% of organizations that use multi-cloud. But if you're going to one of these cloud provider databases because your organization doesn't require high availability, and they're one of those 2% of the enterprises that can be on a single cloud, this tool will make it simple. It makes it very easy. You can do an online migration where it's constantly synchronizing between the database center and the cloud. You can do an offline migration where you shut down the server and copy everything and then move it over. So there's lots of ways to do it. Anyway, when you migrate a database, you have to assess the database. You have to look at the schema and migrate your schema to the target database. And then you've got to migrate your data and verify that it got there and everything is working. So what are the prerequisites to basically using this service? You've got to download that data migration assistant, and then you've got to create an Azure virtual network instance, in which case you're going to lock it down by you're adding your network security groups, your firewalling. You'll set up your credentials, and you'll provision your target database with the right sizing. How about your unstructured data? How are you going to get that there? Well, you've got the storage migration service. And basically, what that's going to do is basically look at your servers, look at your data, look at your file shares, look at your source servers, and it will help you copy it over to the cloud. Pretty simple. The steps are basically inventory your services, your servers, and their files and what have you, transfer your data, and then cut it over the cloud if that's what you're going to want to do. So, what's going to be involved in this? Basically, you're going to have to select your source servers, then select your destination servers. You'll have to identify an orchestrator server that's going to be used for the migration. And then you're going to prepare your PC or your server in the Windows admin server to run that migration service user interface. And you're going to make sure that you've made all your security requirements, the service, Microsoft Service Proxy service, your firewall ports and settings are all satisfied. We also have the concept of Azure File Sync. So Azure File Sync is a feature of Azure Files that's going to give you functionality of on-premise file shares with the benefits of a cloud service. So what's really going on here? It enables you to basically put your files in Azure and then have on-premise connectivity to it. Of course, you could just put these things in your data center, but if we're going to store all that data in the cloud, the performance getting to it's going to be horrible, right? Because we got to go over the network. So what we're dealing with here is what it does is it will cache your files. So you'll keep one of these Azure file shares like virtual machine appliances or servers in your data center. And as you pull information from the cloud, it will cache various information here. And that way you won't have to go to the cloud every single time to access the information. Your servers will connect to this via the server message block protocol if they're Windows, NFS if they're Linux. You can also use secure FTP. So that's an opportunity to have centralized cloud storage and still access it. So why might you think about it? Why might you use this Azure File Sync? Well, you could use it to replace some of your file stores and store them on the cloud. Maybe you in your data center, you keep all your data that's active that you're going to use because it's going to be lower cost and higher performance. And maybe you shift that archive data over to the cloud, but you can still access it when you need it potentially. Maybe you're going to lift up your entire data center and move it to the cloud. That's the goal. You can do that, and this can help with that. We can use this to basically back up our files from our data center to the cloud, and we can use it for backups, disaster recovery, what have we. We can synchronize our files. That's why we're typically using this kind of Azure file sync. Now, we talked about the data box, which is a ruggedized computer. We talked about transferring files over your wide area network, like your VPN or your express route connection. There's also the concept of an import export service. And basically speaking, is basically you basically copy your information to a hard drive and ship it to them. So, that could be done too. Obviously, it's going to need to be encrypted when we're shipping these kinds of things. So when might we want to use this? We're moving a good amount of data and we don't have access to good networking capabilities. We want to distribute our data from basically an Azure storage to a customer site. We want to back up our on-premise data to Azure and we don't have the network to do it. That's typically when we're going to do this. So some things we need to think about is it's only going to exporting data from Azure Blob. You're going to have BitLocker on the Windows systems, and you're going to need to have an active shipping carrier account to be able to ship these drives. Think FedEx, DHL, what have you. And you're going to need a set of disks to export your data. Now, Azure Data Box is not just a disk. That's the next option. This is a big ruggedized computer or something to that effect. With high-speed networking, it gets shipped to you, and you send it back to them. And that's typically called data box. The data box itself, we covered in the first week fairly heavily, as a capacity of at least unformatted of 80 terabytes. And basically speaking, you copy your information and you move it over. So if you're migrating, terabytes of data, this can be something fairly helpful. Okay, next is we're going to talk about designing infrastructure solutions. So, Chris, let's take a quick break, see if any questions actually popped up. When is it the right choice to choose a cloud proprietary migration service? And what other options do we have to consider? Preb, that's a really great question. And I know you said I could call you Preb. It's not that I don't know it's not your full name. So if you don't have seriously high availability requirements or mission critical requirements, then your whole goal is to go from a data center that you didn't really know how to use to the cloud because you didn't know how to manage the data center, didn't have the sophistication, and you're just looking for something simple and easy to go. That's when you use these migration services. If you're dealing with a real business or a big business that has a critical dependence upon technology, you're going to be doing things a little more carefully. So that's the difference between certification and reality. Some of these tools are great. There's a difference between an upgrade of your PC, which you might do in your PC, versus what someone would do if they were going to change the operating of their servers. They're not going to do an upgrade from one server to another. They're going to do a clean install of it. Because in the process of the clean install, they'll get rid of any of the old stuff that was partially broken. In the upgrade, things can go wrong, so they don't risk these kinds of things. So these are basic tools. They're designed for simplicity. They're designed for elegance. And, for small businesses, this might be great. For businesses of less than a few hundred people, this might be great. It really might be. And for even a little bigger businesses, it's there. But when you're dealing with a big business, the kind of businesses that actually call real cloud architects in and real solutions architects in, they're dealing with people that have, $500 million a year of technology spend or $2 and $3 billion a year of technology spend. And it's going to take you and a team of 50 people or more to spend 6 months to a year to understand everything that they have. And these companies are going to have hundreds of architects and thousands of engineers. For example, JP Morgan Chase Bank has 2,000 AI people there right now, and they've had for years. Just AI. Now, when you have a system like that, you're not going to use one of these little silly tools and think it's going to get you there. But for a small business, that's there. Now, when do you use proprietary? Well, in the beginning, many years ago, and we advised people not to do this, and you can go back and you can see why. Lots of people thought they can go to the single cloud. The cloud provider said, well, we're like your electric company. You don't make your own electric. Just go here and just use our systems. Trust us. It's going to be great. And then AWS had a power failure outage, which took down their entire globe. Then they had impaired networks, which I don't know what that means as a network architect. Maybe a router and switch went out and got drunk, and then they were impaired and therefore couldn't forward their traffic, silly things like that. Then Google Cloud was down from a BGP issue, and then Google Cloud took down a $240 billion hedge fund by accident. And then Microsoft had some outages, had some hacks. And so nobody's going to put all their eggs in one basket for a real business and enterprise business. And when I say real business, I'm talking about people that employ a lot of people that are critically dependent upon things, that are doing sales in the billions of dollars per year. Our primary employers that we have, those companies are not going to be using these tools. Now, if me and Chris and Alonzo and the rest of our staff were going to go to a single cloud, we might take the systems that we have in our OpenStack cloud, use these tools and migrate it. But we're a 10-person company for the most part, at least in terms of the staff. Well, actually, we're more than 10 people instructors. I'd say we're 25 if you count all of our instructors. But we could use these tools. But there's no customer that I've ever consulted with in my entire life that wouldn't do a careful and methodical planning. Good question there. Chris, we can go to the next one. So, Cantor Grant, thank you so much. I deeply, deeply appreciate it. So yes, this is what we give you for free. You can only imagine what we do in our 1,000-hour architect training program. That's all about changing people's lives. So let's talk briefly about designing according to the way they would put it. Again, there's a big difference between what we do as architects versus what's in a certification. But, we're in a certification preparation course, so I've got to teach you the certification preparation course. We actually have full architecture training programs that I teach, David Lithicum and other elite architects teach inside of our programs. So let's think about what we're dealing with as we move. Some of what we have to move is going to be the compute or the processing. And that could be, say, a virtual machine. It could be a group of virtual machines that we talked about, like Azure Batch. It could be an app service where we just upload our code and it runs. They can be Azure functions, which are designed for running code in the cloud, where basically little mini strips and snippets of code. They can be logic apps, which are great because they're basically you set up a workflow and it runs. You don't even need to know any coding to make this happen. And we've got our Azure container instances, which is a proprietary container orchestration and container runtime platform. And of course, we've got the Azure Kubernetes service, which is more of an open standard-based container orchestration service. And it's quite good. The only problem is if you're using 3 clouds and your container orchestration is only 1 cloud and your cloud goes down, you got some challenges. But these are the things we need to talk about. And actually, in this case, I have it written down. So let me share that with you so you can think about it a little longer. I don't normally have things written down on slides, but in this particular case, I had Alonzo make me a nice chart. So let's think about the considerations of what we're choosing. What is the level of control that we need? Do we need control, real control? Then we use a virtual machine for full control. If we don't need to know where it's running, how it's running, and we're looking for simplicity, something like an Azure function is great. Then we have to look at a workload. If we have high performance, it's going to go on a virtual machine or a group of virtual machines like Azure Batch. Next is, what's the best architecture for infrastructure? Well, that involves understanding the business goals, the business processes, application utilization patterns, application coding patterns, the number of developers, the level of complexity the organization can have, the organization's readiness for change, and so many other factors. And that's a multi-month thing to figure that out. But, maybe it's a microservice-based application. There's a time and a place that's going to work. If you're Google and you've got 100,000 developers or some ridiculous number of developers and they're all working on different things, microservices is your way to go. If you are a smaller business and you have a limited number of developers, microservices will increase cost and will increase complexity and may not provide any additional value and may be the worst thing the business could do. Same thing with serverless. If you've got an application that doesn't run a lot, use serverless. It's beautiful. If you have an application that doesn't work a lot, that works all the time, do not use serverless. It'll cost too much. So think that in the back of your mind. So really pick the migration path, the application, the compute that meets the business goals, not something you think is cool because you went to a conference and they talked about it. And sadly, that's why a lot of our architectures fail. People go to a conference, they get hyped up on something they think is cool. They actually are crazy enough to convince their manager to do it. The manager doesn't understand the technology. So they say, sounds great. Then they deploy the technology and then the manager gets fired. The chief information officer gets fired. because they did something that was bad for the business. So you have to be a trusted advisor. You must be professional, and you must base it on what the needs are, not any preferences. Now, when we think about moving our compute, what kind of do we need? Is it something simple that we can just use a platform service that's there for us? Like maybe a May API that's made for us? Or managed hosting where we just upload our cards? Sometimes that's the best thing in the world. Other time we need full, but we have no control. Other times we need full control, we use a virtual machine. And that's really what you need to be thinking about. So when we move it over, then we need to think about what's the structure. Should it be cloud optimized? Sometimes that is the best thing to do. Go to the cloud, optimize our workload, refactor our applications, leverage some cloud native features, leverage some cloud proprietary things because they're simple, easy, and elegant. Maybe that's the worst thing for our business. So it goes back to what is the business need? Lift and shift. Take your stuff exactly the way it is in your data center, move it exactly to the cloud, exactly the way it is in your data center, and do nothing. Now, the reality is the cloud providers came up with this concept of lift and shift, and everybody thought it was going to be cheaper, but it wasn't. It was more expensive. And that's why the people that did the lift and shift to the cloud are doing a lift and shift back to the data center. That's the cloud repatriation movement. But here's the good news. Lots of stuff still going to the cloud. And if you're a cloud architect, not a solution architect, but a cloud architect, the kind we train, if they go back to the data center, they're using a private cloud like OpenStack or Nutanix. Lots of money for you to make. If they're going to the public cloud, guess what? Lots of money for you to make. You'll always be available on the cloud, off the cloud, because you actually understand the full picture. So that's why I always focus on cloud architecture. And here's the containerization. Maybe you can take your application and just drop it in a container and run it on containers, and that might be the best thing too. So when it comes down to it, it all is about the business. Infrastructure as a service is effectively purely exactly what we have. But because it's exactly what we have, what do we have to do? Manage the applications, the runtime, the data, the virtual machines, the container. The only benefit we don't have to think about with regards to a lift and shift architecture is the underlying network and the hypervisors on our servers and the physical servers ourselves and the electric. And truth be told, the hardest part to get these systems up and running in most cases is the networking. And to put that into context, it's a CCIE like mine, the Cisco Certified Internet Expert, that covers 10% of all of Cisco networking, was approximately 75,000 pages of reading and 1,000 hours of lab time to pass that exam. By comparison, if you look at the official Azure Solutions Architect training for the certification, it's less than 500 pages. So, you're dealing with, one thing, and that's why the infrastructure is so hard versus something like the cloud, which is so easy. But you won't be able to design it unless you have the full knowledge of the underlying infrastructure anyway. So keep that in the back of your mind. Now, platform as a service, which we talked about before, is pretty much uploading the code, and it provides all the necessary thing. The infrastructure is there, the runtime module is there, and it's just your applications and your data. Whereas the function as a service is just like code. Bear with me a minute. So let's talk a little bit about the costs that are associated with and how some of this pricing is going to be. And I already covered the virtual machines that were there before. And when we covered virtual machines before, I told you the only thing that matters is your CPU performance, your DRAM performance, your storage performance, and your networking performance. The rest of it is all marketing fluff. General purpose, general purpose is a subjective term. It doesn't mean anything. And I'm sharing this because Alonzo drew this so I could show it to you all. So general purpose, that is, what they would say, balanced CPU to memory. What the heck does that mean? It's non-quantifiable. Compute optimized here is what we're really talking about is a lot of CPUs. So anytime you think compute, think big CPUs or CPU power. And that's where you're going to need something heavy. Memory optimized is basically a lot more memory than CPU. Again, these are subjective. So if you had a cache, you would use something memory optimized or analytics or something like this that was there. Storage optimized means lots of speed to your storage. Now, GPU optimized, that's realistically speaking where I talked about that PCIe pass through into your system. And by doing so, you're putting a physical graphics card into your system. So why would you do that? Machine learning, video rendering, that kind of thing. And high performance compute realistically means you're getting a modern server as opposed to something slow. And it's going to be like one of those AMD EPIC type servers, typically speaking, when we talk about high performance compute, where each processor core is like 128 cores or 96 cores, and you got a couple of those CPUs in there. And you typically have 4 to 6 terabytes of DRAM and you've got 100 gig network interfaces or multiple inside that box. Generally speaking, that's there. I thought I'd put that text. I don't have a lot of text-based slides, but I thought that might actually help. So when we think about the pricing, remember virtual machines are priced per minute. And they're based upon the type of virtual machine, meaning the better it performs, the more you're going to pay. To some degree, there's an operating system element too. Some operating systems are licensed, some are not, and that will affect it. Now, storage costs are going to be billed separately. So you have to pay for the system, and then you're going to have to pay for the storage. And then the operating system, you're going to have a lot of options. Windows, Linux, but various flavors inside of them. So that's realistically what we're speaking about, these virtual machines. Remember, batch is virtual machines, but it can scale from tens, hundreds, or thousands of virtual machines. And you're going to use that for a compute-intensive task. So maybe you want to sequence a genome. Maybe you want to do some scientific computing calculations. Maybe you're dealing with the pandemic and you're trying to run some statistical analysis across a wide variety of information, and you're mining information. So that's typically where you would use Azure Batch. Because all it's doing is basically scheduling a pool of virtual machines to do what it needs to do. Azure Batch is going to be great for independent and tightly coupled workloads. So in a perfect world, these are applications where each little task can be run independently. And that for a parallel workload, whereas a tightly coupled workload, we basically need to have like a lot of things doing the same thing. So imagine if you were going to take images from a satellite and you were going to process these things and they were super high resolution images from a whole bunch of satellites to try and find something or someone. Maybe there's a Monte Carlo type simulation if you're familiar with that. So Azure Batch is pretty impressive. And this is one of those things that people love the cloud for, because you can have your beautiful data center doing all its stuff where you get the best performance and lowest cost. And then you can go to the cloud. You can get this huge compute capacity, run these simulations, and pull that information, the results back to your environment. And that's another reason people love hybrid cloud so much. So a little more about Azure App Service, and then we introduced it. We're going to talk a little more. And that's basically an HTTP-based service for hosting web apps, background jobs, mobile backends, RESTful APIs. And it gives us a lot of benefits and features, so we can use lots of programming languages. And that means, you can have this thing running one language and this thing running another language. So basically, you may be able to reuse your own code, which is good. Because it doesn't have a code preference, your developers can use whatever they like, which is also good. So that gives you some flexibility for these types of environments. Azure App Service, should you use it, supports automated deployments from GitHub or Azure DevOps or any type of Git repository you're doing. So that's going to simplify, the CI/CD pipelines. Azure App Service, again, is something that's going to be help managed for you. So it scales automatically. And as long as the cloud is up, you're going to have high availability. But if the cloud goes down, you're going to lose it all. So There's things you need to think about when we're putting through this. You're going to have your repository branches, and that's going to be your different stages in development. So, your primary stage, your staging, your production environments. You're going to have your deployment slots, which are going to be where they're going to go. The primary slot is going to be obviously your main production environment after the builds have been validated and deployed. Your staging slots are typically where you put it before it's going to be deployed, and your development slots are where the initial code is done and testing, that sort of thing. And the process is going to be basically to go from the dev slot to the staging slot to the primary. You're just swapping slots when you deploy these things. If you use Azure App Service, again, it's one of these pre-made things. You don't have to think about it, which means it's going to have capacity somewhere. They're going to have global load balancing because it's going to load share and be placed across their systems. You may not know where, but it'll be there. And it's going to help manage your traffic efficiently. And of course, it'll have capabilities that are built in for authenticating and authorizing users, typically easy auth. And it's going to be very easy to basically set it up to get users to sign in. So the key here is that you're going to have this constant, continuous deployment. So you can go from basically stage to stage. So what's that going to look like realistically? It's going to look like this. Alonzo drew this kind of nicely. So what this graphic is going to look like. And I thought I'd share it with you. So in this particular environment, you see basically your developers put it into dev slot. And they're testing it there. And then they're going to move it to the staging place. And that's that pre-production kind of environment. It's going to sit there. They can test. It gets ready. And then they're going to pop it into that primary state, which is that pre-production, that kind of production environment. And then it's going to swap straight into production, and it'll be there. And this way, when your DevOps engineers are working on these kinds of things, and your developers are working on this, it gives them a platform to test in a safe space, move it up along the route, and only push it to production when they are absolutely ready. And this is typically a lot easier than it used to be to basically pop up a new server and put it in the way we used to. So let's talk about design for Azure Container Instances. And again, this is a beautiful, a simple, and elegant approach that is perfect if you only have to be in Azure. Same thing with the AWS Elastic Compute Service. Beautiful if you're only in AWS. But remember, 98% of organizations are multi-cloud. So we can't use these things in a multi-cloud environment. So it's a proprietary, elegant, simple container orchestration and runtime service. Some of the things that are good is that the containers launch quickly. And by quickly, we mean in seconds, compared to your virtual machine that runs at all times. You're paying per second, which is good, as opposed to per minute if it only runs for 3 seconds. We can specify some custom sizes of CPU and memory value. And it will obviously has the ability to store it in Azure File Storage. And we can run Windows and Linux containers in the same API. So that probably tells you it's running on Windows servers, running the Windows subsystem for Linux under the scene that they don't tell us about. We have the concept of container groups, and that's going to be a large collections of containers that are going to share lifecycle, resources, local networking, storage volumes. And when might we use them? Well, we might have a multi-container application where different containers do different tasks. We might have a web application and potentially source control. We may want the container to pull the latest content from the source control. We may have different containers for our application and logging. Maybe we've got one container for the application, another container to collect the logs and metrics. We could also have containers just to monitor systems. We can have front-end containers for the things that are publicly facing, back-end containers for things in our private network. So we've got lots of opportunities there. We typically want to use a private registry to store our container images, maybe a Docker trusted registry or Azure Container Registry. because we want to make sure that our images in our containers are secure and they haven't been modified unless we modify them. And if you find that you've got a container with a vulnerability, if you don't need to run it in production, don't. And of course, you want to track any resources that you have. Now, the next container orchestration platform is obviously the Azure Kubernetes one. Again, not a great option multi-cloud, but it is an open standard. So you could potentially use the Azure Kubernetes environment. When you're just on the Azure cloud, you're using Kubernetes orchestration. And then later, when you realize you're going to be multi-cloud, like 98% of other organization enterprises, all you'd really need to do is get rid of the Azure Kubernetes service and swap in like an OpenShift Kubernetes service from IBM and pop that on various virtual machines and all cloud providers. And then your Kubernetes is up and running on 3 clouds. Lose a cloud, who cares? Doesn't mean anything. So there's that. So it can be used, and it is a great service. And, there is some complexity in managing Kubernetes. It's not as complex as people think, but it's somewhat complicated, somewhat. And if you don't have the people with the sophistication to know how to set it up, an automated service like this might be good. But if your business is dependent upon, if a business is dependent upon their systems being available, well, the reality is they just need the right people and to choose the right technology. But it's not always that easy. So it's an automated container orchestration platform. And if you go back to that first week, we talked about container orchestration versus container runtime, and we diagrammed that all out for you. It's cost efficient because you don't have to think about kind of running it and managing it. So that tends to help. There's nice templates to automate your cluster creation and how you can easily specify your networking or your Microsoft Entra ID or IAM connections. So it's quite nice, and it's still open source. So anything that you've set up this way will work if you just swap in another Kubernetes container orchestration platform later. So you could potentially use this starting on one cloud. It'd probably be better just to start with an open one, like an OpenShift on that could go to all clouds. But at least you're using something open standards. And why open standards? Well, it's going to make it much easier to innovate later when somebody else says, I have a better mousetrap. Because if you're stuck on proprietary things and then there's something that's new that comes out and you can't use it without making big changes, that's not good. So when we use these kind of platforms that are not open standard, that are not flexible, that are proprietary, we get that simplicity and elegance, but we get something that's called technical debt, or things we're going to have to pay back later the next time we want to innovate. So think about these things as you move forward. But it gives you good identity management. And, are you going to be using your Azure resources? That's to think about. And if so, connect it with Microsoft Entra ID. It's going to give you great logging, so you can monitor your performance of your cluster directly here. It will give you automatic cluster and node scaling, just like you would get with Kubernetes. So you can have horizontal pod auto scaling, meaning increasing the pods based on resource demand. We can auto scale the clusters that are necessary, the cluster nodes if necessary. We can upgrade cluster nodes fairly easily. And we've got some good storage volume support. So that's that. And of course, it's Kubernetes. So you'll be able to set up your networks, like for your pod-to-pod communication. And if needed, we can set up your pod communication in your Azure cloud, as well as your data center or other environments, because it just needs IP connectivity. We can think about ingress routing. For example, maybe you need to make your applications publicly available. We can do that. The solution would be to use the HTTP application routing add-on, which is going to make it easier to do these things. If we need Docker image support, no big deal, because Azure Kubernetes Service does it by default. If we need a private container registry, that's fine. Azure Kubernetes Service neatly integrates with the Azure Container Registry to keep your containers private and secure, at least the images of them. If we had a greenfield project, we could use an open standard based like IBM OpenShift, which runs on all clouds, or we could use the Azure Kubernetes Service to build new containerized services. Some information on Azure functions. Remember, they're serverless. Remember that you pay each time they use. which means they're great if you don't use them a lot. They're horrible if they use them all the time, cost-wise. They're typically wonderful for event-driven architectures where if this happens, then do this. That's typically where we're actually using them. And they tend to scale real well because they can just run all day long. You know, add more as you need it. Now, at some point, you're going to run into a limitation. And at some point, you're going to run into a limitation. And at that point, you're going to have to call them, and they'll allow you to increase capacity, but kind of keep that in the back of your mind. Some language flexibility. Basically, it's going to give you the ability to write code. And again, it's on demand. So here's some best practices. You really don't want to run a long running function. You're going to potentially get timeout. And that's one of the things you're trying to do. So if you've got a function that's taking too long, refactor it into smaller things. We can also use something called the durable function to manage state or checkpoints or restores. And that's going to be better for something that's going to overcome timeout. It's going to make it stateful. So we could chain one function to the other in order. Regarding performance and scaling, we want to plan our function grouping based upon load profiles. Maybe we deploy a separate function for each application inside of the resource needs. And functions that have high memory requirements, we want to separate those from the other ones. And maybe we use queue messages, for example. And, you know, my favorite of these functions is basically defensive functions. So you get attacked and it can do something to remediate it. So this is really where these serverless things come out. So we'll talk a little bit more about publishers and subscribers. So if we're dealing with these distributed architectures, which are sometimes the right thing, and sometimes they are not, but if we are, you know, we've got to get messages from one system to another system. So we typically have a publisher who basically produces a message and a subscriber that subscribes to the messages. So the publishers are going to be the key components that generate these messages. They're going to send message events. And they're typically going to send it to an intermediary device before it gets to the receiver. And that's typically called a message broker or a bus. And generally speaking, the publisher won't know who actually needs to know who's receiving it. They're just publishing it. By comparison, the components, the subscribers are realistically there because they're the people that are going to pull those messages and use those messages. And the message bus is going to be that place that those messages are placed before they actually get to the end systems that we're talking about. You typically think about message brokers being like Apache Kafka, which we typically use for everything in the multi-cloud world. RabbitMQ, it's the same thing as an Amazon SNS. But you see, Apache Kafka works in all clouds, so it tends to, and all data centers. So if we're going to describe these message and event scenarios, what's really going on is we have to design how the application components are going to communicate. And the messages and events are going to be the primary communication between these components. So if we think about the characteristics of a message, it's typically raw data that's going to be produced by one component, which will have to go to other components in the system. It'll include the data itself, not just a reference to it. And the sender expects the receiver to process the message in a specific way. So for all this stuff to work, to have system integrity, we don't just need the message sender to send the message, we need the receiver to actually do something with it, or the subscriber. I talked about this before, but we'll bring it up again. You know, when we're dealing with messages, and it's going to be a lot like routing protocols. If something goes wrong, you're going to get a notification. And whenever we're dealing with these messages, we have that ability to be flexible. It can be sent to one receiver or a group of receivers. It can be fanned out to multiple people. We gave some examples of that yesterday. But the publisher doesn't know what the receiver is doing and doesn't have an expectation. So if you have to choose between messaging and events, there's times where you're going to implement both. So you may implement a hybrid approach where applications will use messages and events. You may have to select which services. Regarding the sender, if the sender expects the receiver to process something, you're using a message. You're using an event if the sender doesn't know or doesn't have any requirements on the receiver. If you need to guarantee communication, you're going to use a message because it's suitable for all communication tasks as they're processed. If you're using an event, it's not going to be guaranteed because what if there's no receivers? We talked about Azure Storage Queues and Azure Messaging, but remember the Azure Storage Queue is going to store a large number of messages in an Azure storage. And that Azure Service Bus is going to be that message broker that we talked about. Bear with me a minute. So let's briefly talk about designing event-driven solutions. With event-driven architectures, the key here is we want to connect that core application without modifying our existing code. We're kind of setting up on that set it and forget it, where basically an event's going to be sent to the next system and the next system and the next system. And it's going to run in response to something happening. So that's really what we're talking about with regards to event-driven. And, we may be using the Azure Service Grid, which is a good event routing service. So keep that in the back of your mind. We may be doing some event aggregation. So we may take all the events and provide some routing to and from any destination. Sources will include things like Azure Blob Storage or Azure Media Services. The key here is we're going to have managed routing and delivery of our messages. We'll have event handlers that will handle the subscribers of the topic. And some examples with that would be like an Azure function could be a great an event handler that we might use. And of course, we've got to go route these events. Let's take some questions here real fast. Get the right. See if anything popped up. Okay, let's see if any questions pop up in the next minute or so. And in the meantime, I'd love to tell you that, what's the word I'm looking for? If you've not signed up for the free labs, please actually go ahead and actually do so. Sign up for some of those free labs that we have for you to offer you, for you to do things on your own time. And if you look in the description of this video, there are a tremendous number of free documents that we have to truly, truly help you in your technology career. I want to make sure you actually do that. And bear with me. And we'll take it from there. So let's see if any questions pop up. No questions about content. Okay. Well, are you awake? Give me a hashtag AZ305 so that I know you are awake. And I'm going to make sure we definitely finish today. We may finish 15 to 30 or 45 minutes late. I'm not sure, but we shall finish today. I see Leo's awake. Who else is awake? Give me a hashtag AZ305. Also, if you're having a good time and you're learning something, please make sure to like the video. If you're not a subscriber, please subscribe and hit the bell to be notified of new videos. Okay, I see some people that are absolutely awake. How about the rest of you? There's 50 plus people on here. Okay, Cantor, I know you're awake. I think you're in Scotland, if I remember correctly. I don't remember where. Brad, I see you there. Okay, so now we're going to talk. Okay, now I know you're awake. Okay, so we're going to talk a little bit about the Azure Well Architected Framework. And I'd love you to know actually how to use these frameworks. And Chris from my team, I made a video on TOGAF versus the AWS Well Architected Framework. Please share that video. And in that video, we talk about when to use an actual digital transformation framework like TOGAF or Zachman, and then where to integrate these cloud providers' well-architected frameworks. Because there's a lot of good in these well-architected frameworks, but they, for the most part, they're based on more of the tech than they are the business. And if we drive a business with tech, we ultimately hurt the business. And we typically come up with solutions that are wrong 70+% of the time. And that's why 70% of architectures fail. If we do it right from the business goals and then add in the tech, we have magic. But if you think about it, let's pretend you were a construction worker, right? You would think about what tools you would bring with you that day before you would do the construction. And you would do that. You wouldn't just go to the store and buy every single tool off the shelf and put it in your van. You think about the work that you're doing and what you're doing and how you're doing it. And, when we look at TOGAF or we look at Zachman, that focuses on every part of it that the business actually needs. And when we actually look at the, what do you call it, piece? The well-architected framework, that's kind of specific to just the tech, and a real architecture takes the combination of all of it into a holistic package. So please see that video on TOGAF, not the TOGAF versus AWS framework. And you can also see the TOGAF versus Zachman, and they're kind of your two biggest enterprise architecture frameworks. Of course, consulting firms also have their own. So what is the Azure Well Architected Framework? Well, it's a technical framework, not an architecture framework, more of a design engineering framework on designing and implementing and improving your technical systems. Now, the key is you have to balance business requirements with technical capabilities, but these frameworks don't teach you how to do that. So they're predominantly on the tech, and they say make sure it meets business needs. Well, yeah, but they don't talk about what that is. The goal here, and it's going to be everybody else's thing, is, your pillars of a well-architected framework. One is going to be cost optimization. And if cost is your concern, maybe cloud computing is not your best option, but it will design what they think under normal circumstances for normal customers, not necessarily you, will be most cost effective. It will help you identify potential inefficiencies and waste in your spending, and it will ensure spending aligns with the best business value. Regarding operational excellence, well, it's not going to give you that either, but it'll talk about how to use modern development practices like DevOps, which will give you faster deployment. And honestly, if you're on the cloud, speed and agility is one of the main reasons you're there. You're not there for cost savings. So for that, this piece is great. It'll teach you how to implement robust monitoring procedures to detect failures, which is good. It may not list all the tools you may use. It may be other vendors outside of Azure use, but that's great. It will help you figure out what things you can automate, what processes you can automate to maybe reduce variance in your systems, errors in your systems, all with the goal of increasing agility. It will help you think about the performance in your systems to help you match your resources with your actual needs and promote scalability. It will teach you how to design for dynamic scaling, which is great, because one of the other main purposes of the cloud other than agility is that ability to have that reserve capacity when you need it. And it will teach you how to make sure your technical architecture, not your cloud architecture, just your technical architecture, will adapt to changing dynamics technically. It will give you some guidance on how to design for failures, but remember, for the most part, it's about how to design stuff on the Azure cloud. If all your systems are just on the Azure cloud or just on the AWS cloud, you've architected in a single point of failure, which you may not want to do. So you've got to be careful with these reliability suggestions that come out of it. And it also gives you some security suggestions. Securing access through authentication, protecting your network through vulnerabilities, using encryptions, incorporating security. Again, you may want to contact the security vendors whose primary business is security for these things, but it's what's in here. Now, there's some general design principles that are here, and some of these are great. And one of them is to allow for architectural evolution. Yes, you want to set up your architectures to be flexible, to be agile, so that as new technology comes into place, you use it. One way to do that is not use proprietary stuff, because it locks you into the ability to not do that. So that knocks out 50% of the things that are in most certifications. Use data to make decisions. Yes, this is great. That's, go out there and analyze the business goals, analyze the business pain points, analyze the technology, analyze the current pricing, analyze every factor of everything, and then use that to plan. Whether that's cost, performance, the number of clouds you use. Yes, absolutely. Now, realistically speaking, the educate and enable, this is pretty important. Your teams constantly need to get better. And if you find something and it works, share that as a best practice so others can benefit. And the key also here is automating. And why are we automating? What's the point of automating? Well, it enables an organization to have less staff, which means less operational costs, or they can retask that staff that's doing things that don't add business value to do things that do better business value, assuming those people get retrained and have the desire to do bigger functions. The other reason we automate is because if I've got 1,000 people that are manually entering stuff, there's going to be a lot of errors. But it's one of the reasons I say there's no more entry-level jobs, and that's why we train architects. But even DevOps engineers, one DevOps engineer can replace 50 or 100 cloud admins because they can use that infrastructure as code script and automating. And that's why you see DevOps becoming so important to everything we do in and out of the data center for that reason, automation. Part of understanding this is to think about what kind of responsibility model you have and the shared responsibility model, which means you are not in complete control of your security of the cloud provider. You have your part and they do their part. You can only hope they do their part correctly, and you can see when they don't with all the cloud outages we have or the cloud hacking events that we have. And you can see all the people that don't do it right because they think the cloud provider is doing for them, and that also can be careful. So I hope that makes sense. And here we've got design choices and trade-offs. We need to think architecture is really about looking at every option you have and evaluating all trade-offs. That's it. If I go from microservice to monolith, what do I gain? I gain simplicity. Well, that's a good thing. I don't need as many developers. That's a good thing. Now, what do I lose? Okay, maybe I lose this flexibility. Okay, fine, but go back and forth. It's the trade-off. Why did companies go to the cloud and all of a sudden went back to the mainframe? Well, the mainframe had that same scalability, but it could handle transactions better than anything else out there. And that's why you see banks that were being told go to the cloud and it's going to help them. All of a sudden, they're investing in mainframes because it did certain things really well. And that doesn't mean that mainframes are right for everything. It's great for very high transaction workloads, and that's their strength. Incidentally, you're seeing more artificial intelligence being done on mainframes too, not just GPUs or CPUs, because of certain things that mainframes do well. But the point is, we've got a selection of hundreds and thousands of different technology options. Evaluate each and every option that's going to be best for the business, figure out what it does best versus what it doesn't, and then you pick it. And that's why there's no best technology. Because the thing that's going to be best for hospital A will hurt hospital B that does something different. Maybe hospital A does only elective surgeries where people fly in and pay cash for them. And hospital B works in an environment where they deal with a lot of poor people, and they're dealing with primary care for people that don't have primary care providers. And they're dealing with trauma and emergency medicine. Well, it's a completely different business model, and both organizations need different technology. And both of those sets of people need great quality care. Now, when we go to the cloud, we have to think about cost. There is a shift from a capital expense to an operational expense in the cloud. Is that good? Well, it depends on the business. It depends on its cost of capital. It depends on what's on its balance sheet. It depends on its cash flow. And all of that needs to be evaluated for the business. Sometimes a capital expense is better. Sometimes an operational expense is better. Sometimes blended is better. And that's where finance professionals earn hundreds and hundreds of thousands of dollars a year to evaluate this stuff. That's one of the reasons executive architects can also earn $500,000 or more a year, because they understand this stuff and they don't just make recommendations that can hurt someone because they don't know. Same reason. And there's a lot of finance in architecture. So if we think about cost optimization, we have to plan our costs and estimate them. We have to think about what resources we have, what resources we're going to need, what costs would potentially be there for redevelopment, what type of services we need, which ones we shouldn't. And then we need to think about cost estimation tools. Then we need to show that to the various stakeholders in the organization, see if they agree with the calculations we've run, get their feedback, and believe me, our first calculations won't be right. Then when it comes time to going to the cloud, we've got to optimize it. Figure out what are the service levels for our workloads. We need to adjust them, take advantage of discounts. For example, maybe you bring your own license because you already paid for the license, so you don't pay for it on the cloud. Maybe you know your systems are going to run at a certain period of time, so utilize reserve type instance. In some cases, it'll be cheaper to run platform as a service. In other cases, you need infrastructure as a service for control or performance. There's less maintenance activities on platform as a service, which means you need less staff. There's less control. So you really want to evaluate your feasibility and understanding, is it better to go to platform as a service? Now, on an exam question, platform as a service is often cheaper. In reality, it may not be. But this is the difference between certification and reality, which is pretty much everything. From a cost optimization perspective, monitor your systems, gain insights, look at your analytics. You're getting large spikes in networking traffic, maybe there's some other thing you can do. You're getting a whole lot of auto scaling of your systems. Well, maybe run some bigger systems or reserve some systems because you see you're using them. Really think about where your systems are running. Do you have a lot of unnecessarily running virtual machines? Get rid of them. Are you paying for unused licenses? Or my favorite, you work in a company and they have 10 licenses for the same thing and they don't know it? Go fix that and consolidate them, knock them down. Are they using high cost storage for infrequently accessed data? Go fix it. Are they constantly building things in non-production environments and spending too much money? Limit that, police it. Or is there an opportunity to reduce our data transfer costs? Use it. Is there an opportunity to use data caching that may reduce the load on your virtual machines where you need yes of them? If the cache is cheaper than that, use it. But the cache only works if your traffic is similar each time. If your traffic is constantly varied, the cache will cost you money and add latency and hurt your performance. So if you've got data that you don't use, archive it frequently. There's some of the things you can use. Think about where your networking is. Maybe replicating your data to different regions is cheaper than inter-regional transfer, but it may not be. So that means looking at it and analyzing the performance of your system. You're starting to see why this takes time? I hope so. It's not just a simple anything. Look at your resources. Some businesses have resources that they don't even know why they're running. They've just been there for years. They aren't even used. Some businesses have this little mini server, a virtual machine sitting under somebody's desk, and then it's key, and they didn't even realize what it was like until the user got fired and they unplugged his computer. But you've got to find it and figure that out. So there's always so much that goes into this. So for driving operational excellence, they recommend, using DevOps and continuous integration and continuous delivery. Automate as much as you can with infrastructure as code to reduce your staff. Automate your application testing. Now, you automate your application testing and you don't thoroughly test it, and then you have CrowdStrike pushing bad code and knocking down airlines and computers across the world. That doesn't mean you shouldn't automate your testing. It means automation is part of your testing, but it's not a full set of testing. And that's why these recommendations you got to take with a grain of salt. These are Azure recommendations, not mine. DevOps culture. So, breaking down those silos between departments. Yes, this is great. The worst thing you can have is all these different technology teams that don't talk to each other, and a business that doesn't talk to your technology team. That's a recipe for disaster. So embrace collaboration and foster it. Really monitor your systems. I mean, make sure you've got a good comprehensive monitoring and logging system. Have some kind of a security information event monitoring system to see what's going on, to correlate events and hacking before they become a nightmare. Use a multi-layered approach and get data everywhere. Get alerts everywhere. Track your spending from everywhere. Heck, collect your data and run AI on your data and analyze your data to see if it finds patterns of behavior you don't. I mean, this is the kind of level of detail we're talking about. Now, anything that can be automated, automate. Why? It reduces human error and the need for staffing. So if I've got someone doing something that can be automated, the business has a choice. If they want to work and they're highly motivated and they're smart and fungible and willing to learn, you take that person that was doing something that's low value, company sends them to training, $10,000, $20,000 of training for a couple of weeks, and poof, they can do a bigger job and add more value to the company. And $10,000 to $20,000 for training is nothing. That's what a normal training cost would take to kind of give somebody some better things in the corporate environment. And they're happy to spend it if the person's willing to do the job. So regarding performance efficiency, make sure your applications have what they need. So the first thing you need to focus is on finding bottlenecks in your system. Maybe the code is written on the system that's so big, sloppy, and cumbersome that it needs 10 times the performance. And you can see it all the time. When I started working in networking, routers had 16 megs of RAM and a 25 megahertz CPU, and they had to run complicated routing code and make decisions. Now I've got a workstation in my house that has 64 cores running at roughly 3 gigs and a half a terabyte of DRAM, and it's my desktop. I mean, let's be fair. I can run sloppy code on that system and it's still going to work. But when you're in the cloud and you're paying for everything and everything's so expensive, if you can optimize your code, you can optimize your compute, which means lower cost. So scale up, scale out, determine what you need to do, and then reserve capacity based upon what you need. It may be cheaper to run a whole bunch of small servers than it is 2 or 3 big servers. It may be cheaper to run 2 or 3 big servers than it is to run smaller servers. Calculate it out. On your networking, tune that to the absolute best as you can, and you don't have the optimal things here, but maybe one path is cheaper than another path. So make sure your routing table is played to the cheaper path if it's going to get you to your goals. Select the right networking and storage technologies. When it comes to storage, figure what you need. Maybe design your data into various partitions to separate management and access. By doing so, you may improve scalability. You may remember these data systems are slow, these drives are slow, so it'll reduce contention for performance for the drive, maybe read or write, if you partition it more. If you've got slow storage and you're constantly hitting these servers, maybe you can cache some of these things and potentially improve the performance. And that might actually be something good too. Really look for bottlenecks. And I'm going to tell you right now, bottlenecks often occur in the network because I've been spending a lifetime finding them. But bad code, one system's dependent upon some other system, and that other system is undersized. So you've got all this stuff running great, and you got one little tiny bottleneck, and it brings the system to a slow grinding halt. And you're paying a lot of money, and it performs horrible, and it's one thing that just needs to be fixed. And realistically speaking, this is an iterative process. You're going to find one bottleneck, and you know what happens? As soon as you fix it, you're going to find the next one, and the next one, and the next one. Now, from a reliability perspective, here's the thing. Your systems need to be available when needed. And how do you determine what level of availability is needed? That business needs to understand what is the cost of downtime. That means those architects and those business people need to get together and figure out what is a minute of downtime cost the business? What is an hour of downtime business? How much downtime can that business tolerate before it has irreparable business damage? And design a solution that maximizes that business's return on investment. So if you really need high availability, don't use a single cloud. I mean, seriously, don't do it. Because when that cloud gets a problem, you've got an issue. And that's why the people that have been designing networks for the last 30 years, I love AT&T. It's a great internet service provider, but they wouldn't have a primary link and a backup link on AT&T. That would be insanity, because when AT&T has a problem, you lose both. So they use AT&T and Verizon instead. If it matters, they're going to use more than one. So there's that. But if you're in the cloud, this is a certification exam. I'm going to tell you to maintain uptime through localized incidents and temporary conditions. I'm going to tell you to integrate high availability into each component and eliminate single points of failure. Yes, but the single cloud is still a single point of failure. Cluster your virtual machines so you don't just have a single virtual machine. Use a bunch of virtual machines. One fails, who cares? Use a load balancer that runs health checks. Load balance your systems across various parts of the cloud or clouds. And by doing so, if a data center or an availability goes bad or a region dies, who cares? You got another cloud or another data center or what have you, another region. Quickly eliminate, really look at incidents and fix them. Now, we talked about disaster recovery. We talked about recovery point objective, which is exactly how much data you can tolerate losing. We talked about maximum tolerable downtime, which is not in this, but the maximum tolerable downtime is the maximum amount of downtime the business can tolerate before it separates irreparable damage. So the recovery time objective in disaster recovery must be less than the maximum tolerable downtime. Otherwise, the business has problems. Perform an analysis of any potential data loss before we do absolutely anything. Evaluate strategies for backup, restoration, and disaster recovery. Where does your disaster recovery people need to be? What people need to be activated in a disaster? Where do they need to be? Who do they need to be? Who needs to speak to the press in a disaster? What do your lawyers need to do in a disaster? Where are your people going to fly and stay during a disaster? So all this stuff goes into this architecture piece. What about protecting the business's reputation? If the systems are down, are you going to give people an honest answer? Microsoft Azure said we were down to a DDoS attack, or we were down because we were hacked. Other cloud providers have given situations that don't even sound believable or possible. If somebody tells you they've been hacked, you get it. It happens. It happens to everybody. It even happened to Fortinet recently, the security company. If you give people answers they don't believe, they might go somewhere else. So all this stuff is there. But when your systems go down, it generally is not good for your brand or your reputation. That's why Amazon doesn't just use their own content delivery network. They use multiple content delivery networks. Why? Because imagine Amazon goes down because CloudFront goes down. They look like fools. But if CloudFront goes down, Fastly is still up and Akamai is still up, and they're still up. So they wouldn't limit themselves to one content delivery network. So that's what we're really talking about under reliability. Security. You must maintain security. So what goes into security? Well, for real, it involves identifying an organization's assets and quantifying those assets and determining the threat landscape and the vulnerabilities that are actually there and determining, what you need to do to protect it and what is the cost of a breach and in terms of quantitative and qualitative. What are the costs for not meeting legal and regulatory requirements? What happens when the businesses are affected? So all that kind of stuff goes into security. So it's critical for that. And it prevents embarrassment. It prevents financial harm. It prevents distrust in the organization. So, the businesses need to quantify the quantifiable things like the cost of downtime, the cost of whatever assets they have. Maybe they've got a new $3 billion new drug that they have the secret formula for. They're going to spend more money to protect that than cute photos of my cat, Cindy, who's the cutest cat, at least to me, because she's my baby. But, that kind of thing. Maybe there's laws like HIPAA or PCI DSS or GDPR. And now, if you get hacked, the government fines you for being hacked. So you're a victim, it's costing you a fortune, and now you get penalized and fined for being a victim. So, there's that too. So organizations now need to spend more money to protect themselves from these things. So what do? Well, one of the things that you need to use is defense in depth. And that means multi-layered approach to security, like an onion. And in that, describing defense in depth, I could spend, literally speaking, 3 to 5 weeks on just that, 5 hours a day to talk about how to do that. But layers and layers and layers of security. So at the data layer, and this is just scratching the surface, but this is what's in an exam. It might be things like exposing weak encryption keys or use strong encryption. At the application layer, it might be things like input validation, prevention of SQL injection or cross-site scripting, so secure coding practices, that kind of thing. At the virtual machine, it might be locking down the operating system, anti-malware software, host-based firewalls, host-based IDS, patching for anomalies, network security group protecting that area. At the network layer, it's going to be closing unnecessary ports. It's going to be using firewalls, IDS, IPS systems, security groups. If in a private cloud, it would be things like traffic shaping, traffic policing, quality of service to make sure that you could prioritize real traffic over, say, worm traffic. Perimeter security, meaning firewalls and more. And that's just a bare minimum. IDS, IPS systems, rate limiting, limiting certain traffic that's going to hit your systems. Network monitoring, DDoS protection. At the access layer, it's going to be things like identity and access management, principle of least privilege. At the physical layer, that's going to be a lot. Locking your systems, for example, down, locking your data center down. Potentially, you need armed guards. You may need dogs. What are you using for fire suppression? Do you need turnstiles? Do you need gates? All this stuff goes into physical security. And you really need to protect about attacks that occur at every layer. So scratching the surface of security would be encryption, secure coding, patching, firewalls, DDoS prevention services, IAM, that type of thing. And now we got to remember we have a shared security model. So what does that mean? It means you manage your stuff and you hope the cloud provider manages their stuff. It also means that you're going to be exposed to security vulnerabilities that you can't prevent. For example, you could have locked your systems completely down perfectly, and then hackers broke into Azure Cosmos DB and they stole thousands of clients' information. Microsoft's great at security. They're awesome at it. But if you were a hacker, who would you hack? Personally, the cloud providers would be the best highest value targets. You get into the cloud provider, you get into a third of the businesses in the world. So hackers are going to be going for these systems all the time. So you need to do as much as you can to protect your systems and minimize the risk when that cloud providers get hacked themselves. But you can't control that. Now, when it comes to cost management, here's the thing. The right architecture protects the needs to spend too much money. When I train architects in our cloud architect career development program, it's 900 plus hours of architecture training because that's what it takes to train a real architect. If you just go by what's in a certification, you're going to have cost overruns, performance problems, your architectures will fall apart, and you won't even know where to begin. But FinOps is a new discipline that came out of people that designed the bad architectures for the cloud. FinOps is what happens after you messed up. So you've got two options. Option one, I used to tell my patients when I practice internal medicine is I'd like you to lose weight. I'd like you to start this exercise program. Here's the diet I would like you to eat. That's architecture. FinOps is my patient ate McDonald's French fries and cheeseburgers for breakfast, lunch, and dinner. My patient is now 350 kilos or about 800 pounds. They smoke, they don't exercise, and now I need to give them drugs so they don't get a heart attack. Well, FinOps, which is what's going to be recommended here, is what's happened after you've done it to look and see what you've done. But good architecture prevents the need for FinOps. FinOps is about tuning. So don't design it right in the first place, and you don't have these cost problems. But even if you do all the right things, at some point, wrong things will happen. And that's where FinOps comes in. So we do need FinOps, but we need better architecture in the first place. So develop a good business case, understand the cost, understanding every component of the expenses, segment the expenses, see what goes in the data center, see what goes in the cloud, forecast the total cost of ownership, and check and see if your forecasts are right. Look at your infrastructure, your support, your network transfer costs. And if you don't know your network patterns in your data center, you have no idea what your network traffic is going to be like in the cloud. So maybe you've got some Cisco NetFlow data on your routers that give you some of these things, but look at it, look for it. Develop a cost model, estimate a realistic budget. And that means not the perfect budget, which is everything is the perfect the way it is. It's there. So generally speaking, there's a way you do a budget. You look what you think it is. Then you add a percentage of being wrong. Then you add a fudge factor, bump it up even more. And then it's usually more than you thought it was anyway. So do some accurate financial planning. Set up budgets to really prevent overspending. So make sure you have the right communication. This means starting with the C-suite, understand their business, understand from the stakeholders, understand get feedback, get a total understanding, create something, show it to them, present it back to them, get their feedback, come back. And that's why architecture takes a team of 15 to 50 people, 6 to 12 months to do this right. That's why we architects are leading teams of all these people as opposed to being able to touch the technology. We can't. We're too busy trying to do this stuff. Think about, cost efficiency. Every architecture we do, every decision we make has a financial implication. Let's figure out what it is. Sometimes buying is a lot cheaper. Sometimes building is cheaper. Sometimes the data center is cheaper. Sometimes one cloud provider is cheaper than another. Sometimes one cloud provider will give you a better discount if you're willing to give them a press release. So all this stuff has to go in there, and all these things need to be calculated if we're going to do it absolutely correctly. So we're going to design it, measure it, consider the impact. And with anything else, you have to build the business case and calculate the return on investment to show the value of the solution, because nobody's just going to wake up and say, I want to buy this stuff. So think about, is it better to buy or use a consumption-based model? It depends. Some systems that need to run 24/7 by 365, buy them. Other systems that you're going to use sporadically, consumption models where you pay per use or pay for time, is great. When you optimize your high availability design, active typically is going to cost less than active passive. And here's why. 50% in AWS, 50% in Azure is going to be much cheaper than 100% in AWS running and 100% in Azure doing absolutely nothing. And if it fails over, we're there. Now, there's times where we can do it, but 50%, 50%, and then use auto scaling means if the traffic leaves one cloud and it goes to the next cloud, it auto scales and you got everything. So think about that. Active passive gets expensive. If and when possible, consolidate our resources or co-locate them someplace with high density. Reduce the number of resources that we're using. Commit to long-term usage of something and get a discount. And why are we getting a discount? We're giving predictable revenue to the cloud provider. If we've got lots of things that are getting expensive, let's switch to a fixed billing environment, kind of like the price fix menu you go, where you just know it's going to be $100 per person at a fancy restaurant, which is a lot cheaper than walking into that restaurant and buying you a bottle of wine for whatever it costs, and then realizing that your steak costs this, and then your broccoli. And if you're like me and you eat 3 sides of broccoli, that becomes more expensive than your steak. And the next thing you realize, maybe you're looking for a sweet potato and might be cheaper to use the price fix. Well, this is the same kind of thing that we're talking about with billing. Sometimes it's cheaper to use fixed pricing. And if so, do so. And monitor, monitor, monitor. Continuously evaluate and refine your costs. That's one of the best things of the cloud. It's so easy to change things. Whoops, this isn't right. Fix it, redo. So you're going to have an operations team that's going to manage these things. And they should be looking at about it, and they should be there. And if you're not familiar with the way these things work, you're going to have an architecture team that designs it. And we design it, we present it, we sell it, we build our business cases, we respond to our RFIs, RFPs, RFQs. We present at briefings, we do these things. If there's a proof of concept, we show up and the engineers do it, and we keep everybody happy along the way. Then there's going to be an engineering and a DevOps team that's going to build it. These are going to build these things. And when it's done and it's built, it's going to be sent over to an operations team. And they're going to manage these systems. And they're going to be constantly looking at this stuff. They're going to be able to see what the resource utilization is, what's going on and what's not going on, because of the maintenance and operations team. When it breaks, they're going to send it over to a tech support team. These teams are very this way. But, your operations team needs to be constantly communicating with your FinOps team to make sure that the costs are utilized, and the FinOps can work with the operations people to see, what they need to do to keep things going and right size the cost. And when they find something, they got to go back to the architects to go redesign it. So constantly look at your systems, retire systems that you don't use, resize underutilized resources, expand what you need to. So that's really what we're talking about. Now, on the development side, maybe we have different software development lifecycle environments that we can use to save costs. Different environments that have different performance levels, for example. Differentiate non-production environments from production environments in terms of features or SKUs or instance counts or logging. Create pre-production environments on demand and get rid of them when you're done. Now, we're going to talk about DevOps. Again, DevOps is not architecture, but we need to think about the operations of these things and who's going to build them. So if we can use an environment that provides agility, if we can provide a collaborative environment between the people that actually run this stuff on an ongoing operations environment versus the developers that write the code, and we can break down those two lines, we can get these things more efficient. If we can use automated tools to help with the testing and help with the staging, and it's going to reduce cost. If we can use infrastructure as code and have one person do it versus 100 people to do it, it's going to reduce costs. And all that gets better when we use standard communication and project tracking tools so that everybody's aware. Teams understand the right paths, the right people, who they're talking to. We get good collaboration between team members with good communication. So this is not a place, and I like Slack. I use Slack all the time. But this is not a place where you WhatsApp message somebody or Slack message someone and they do it. Most of these things take a phone call or a video call, the ability to ask questions back and forth. And when you don't do that, you get a communication error, and a communication error causes problems. Most problems are caused by poor communication. So use standard communication protocols. Don't use acronyms. Don't use silly abbreviations. They confuse things. Clear, appropriate language, simple language. Get into that concept of continuous improvement. So we want to get better. We want to get better. And we're constantly looking for ways to refine. About 20 minutes or so of content to go, maybe 25. I want to finish that, and I'll take questions. I'd like to make sure that I can say we finished it this week. And that enables us to, in the future, come up with some pretty fun workshops. So realistically, in the deployment procedures, Anything we can do to make these things come out. So set good standards for how your systems are developed, how your code is formatted, naming conventions for your systems, version control, error handling, minimum baseline systems for security. Not only does it prevent issues, it provides clarity. So when it comes to an operations perspective later, it's easy to figure out what's going. And when those tech support teams have to troubleshoot it later, they're going to be there. One of the things that we should think about is observability. So we want to continuously see what's going on. So we should enable short-term and long-term decision making with data, with statistics. And it shows us what we're doing and what's working and what's not working, those kinds of things. We can anticipate issues before they affect the customer. We really want to start looking at our workloads through telemetry. Whoever those engineers are in the operations point, we need to see what's going on, because things are always going to break, and we're going to have to prioritize based upon the severity what we do first. And telemetry data can be used to help troubleshooting things like logs, for example. We want to look at what our operations people really want to find tools that will give them as much as they can in a single dashboard. Why? They'll be able to look at it, and if it's clear and the operations team says there's a problem and they see there's a problem, they can escalate it to management, and management can then send it to the architecture team to create a new architecture to go fix it or to re-architect the solution around it. And obviously, we need some kind of a good alerting system. So when something goes wrong, we don't want to not know about it. We want to know about it. We want to get the right people involved. So when it comes to setting up these environments, you almost want to set up like a supply chain. And that way you can ensure predictability across your environments, your hosting platforms, your applications, your data. You want to enable your automation testing and monitoring and versioning. If you can modularize your deployment things to make it easier to execute on demand, do so. And that's really what you're trying to deal with. Infrastructure as code. This is, in today's world, it's kind of a must, which is why I tell people don't ever try to get a junior level cloud admin job. There are none, or there are almost very few. You can get your first job as a cloud architect, and I have examples. You can get your first job as a cloud engineer. You can get your first job as a DevOps engineer. Don't train to be junior level. Train to be great. An airplane pilot's first job is an airplane pilot. A physician's first job is a physician. A lawyer's first job is there. My first job was a senior engineer, and within 3 months, I was a lead architect. Why? I trained for it. So again, these things should be terrifying for people that are preparing for entry-level jobs like infrastructure as code. So train to be great. Whatever you think you need, try to be 10 times better, and you will always have a job, and you'll be paid better than you can imagine. And you don't need to start at the bottom. And keep that in mind, because companies don't need that entry level anymore. So train for one of these bigger careers, and infrastructure as code and AI are the driving factors. Companies will be using infrastructure as code. They will be deploying these systems almost effortlessly with infrastructure as code, typically speaking Terraform. So develop, standard code templates, these infrastructure as codes for your DevOps engineers and your cloud engineers that are going to do these things. Automate for efficiency. So many of these things can be automated. Automate them. And analyze everything that goes along based upon complexity and effort and frequency and accuracy. Automate anything you can and free up time. And that either means you, hopefully, if the people you have that are good, you can retrain them for bigger and better roles so you can keep them inside of your system. Treat automation as, realistically speaking, one of the key components of any modern architecture. How can you make it simple, easy to maintain, and with the minimum number of people as possible? So when it comes out to deployment, apply a lot of rigor, code, and configuration to every artifact that you have, or piece of code, or anything that was created called an artifact. An architecture document can be an artifact. A piece of code can be called an artifact. What the key here is, you're making sure that it's predictable, that it's going to work, and it's going to be smooth. And as soon as you roll something out, test it. It's not done until it's tested. When it comes to performance efficiency, come up with realistic performance targets that are going to be based upon the business needs. If you need 99.999% availability, there's probably 25,000 of us in the world that know how to do it. I've been doing it for the last 25 years. Most people don't know. So that's not realistic for most people. For 99.99 is realistic for most people, which is 52 minutes in businesses on the downtime per year. If you need 99.999% of the time, you're going to need to have heavy duty, highly educated, highly skilled infrastructure architects, because it's the infrastructure that's going to go down. So understand it, measure it, correlate it, and see what you can do. Now, in everything that we do every day as architects, it's going to be constant negotiation. This business unit wants this. What you do for this business unit hurts this business unit, so you're going to have to negotiate it, which is why we teach so much negotiation skills to architects, and it's so critical. Nobody's going to take your first architecture. You're going to have to redesign it 5, 10, 15 times. We're going to have to set, and we're going to have to look and test it across various situations. So there's that. Then we create our architecture, and while we're creating the architecture, there's some changes in market dynamics, regulation that could change our architecture. So when we're designing these things, we're going to have to factor every one of these components in and evaluate these things, and then make informed decisions based on practical insights, expertise of the people that have done it before, numerical guidelines and statistics that you can get from consulting firms, other firms that have done it. Sometimes the providers can have it themselves. And we are going to have to find focused performance targets based upon feasibility, industry best practices, and market trends. Our business teams are going to have finance people. Our architects are going to need to know finance. They're going to work with it. Potentially, an architecture is going to hit the chief financial officer, the chief technology officer, the chief information officer. Many times the CEO, the chief executive officer will be involved. There'll be business analysts that'll be there. There'll be management and strategy consultants that are going to be involved in this. Lots of RFIs, RFPs, RFQs, and all this stuff is going to go back and forth for a long period of time. And all this is going to go to the stakeholder. You'll show them something. They'll suggest something. Then we'll create an architecture. And then, of course, there's going to go some pricing negotiations that'll go on for months at a time. Then legal negotiations. So, it's not like a certification. So I'm trying to give you a little bit of the guiding of what's going on while we talk about the well-architected framework. It's the best job in the world. I'll tell you, there's nothing this great, though. Honestly, it's wonderful. And after 25 years as an architect, I can't believe people pay me to do this. It's like a hobby to me. I love it. I love making businesses and people's businesses and changing hospitals and make people's lives better. So when we're negotiating these performance targets, we're going to be with the business owners. That's that C-suite or those key stakeholders. We're going to maintain a broad perspective of things because we can't get too granular. The second we architects go down in the details of something, we lose that big picture. So we're going to have to be explicit about expected terms. We're going to focus on that big picture. Thankfully, we have a team of people that'll help us with those lower level details. We have to avoid any assumptions. And if we make assumptions, we have to document them and explain them. We need to be clear of what's the motivation behind the team. What are their goals? What is that organization's measure of success? Because if we don't know their measure of success, we don't know what we're going to get them to be successful. And if you had let's say you were an archer and you were trying to hit a target, if you didn't know where the target was, chances are you're going to miss. And that's really what goes on in most of these environments. So we have to get the target. What are we going to? What's the business goals? What's the measure of success? And sadly, it's not discussed in any of these architecture certifications because they don't cover architecture. But they'll still help you get an interview, so they're definitely worth it. So we have to really meet with the business partners, gain consensus on general targets. Now, we architects will have to conduct proof of concepts. And what does that mean? It means me coming in with a team of engineers that I'm going to tell them the architecture. They're going to go build this. I'm going to take care of the engineers. I'm going to meet their needs, buy them lunches, dinners, drinks, be there to support them, introduce the team of the client with this, be there to make sure that the proof of concept works. If something doesn't work, I'll call management and bring in additional resources for that proof of concept. And during these proof of concepts, we have to show it to the client, make sure that our team of engineers demonstrates it while we talk about the business applications and show that it can work. When we design our things, we need to prioritize workloads and workflows. So we have to think about every entry and exit point along the way. We have to think about which things are necessary and say the critical path. For example, sometimes you have to do this first before this and then this. That's called the critical path. We'll have to determine everything that we need. We'll have to the benefits of this is to understand what's going, what's acceptable, what's unacceptable, how it'll be used. Does it support the workflow of the business and the organization's needs? Realistically speaking, we want to proactively measure performance and establish baselines. And we want to do this early on and see what it works. And then we can see as our architecture potentially drifts or changes get made over time, are we still keeping those levels of performance? And if we're not, what do we need to do? We may need a new architecture. So there'll be a new architecture process that needs to be done. And a good architecture process starts with the architecture vision from the company, evaluates the business and the business processes, the business architecture, determines what new business architecture or how the business needs to occur in the future, then evaluates the current technology platforms against the future business goals, and then adopts the architecture accordingly. Then we're looking for opportunities and platforms and enhancements we can make, for example. Then we want to see if the organization's ready to take these changes. Do they have the sophistication to do it? And determining what has to happen when changes have to happen. Every time we need to make real changes, we need to do that. So as well as develop a process for change. So if it's meeting things, but we don't know it, but you got a baseline early and then measure this along the way. Now we should be thinking about how we can make our workloads move right by choosing the right resources. Just because you like serverless and containers doesn't mean they're the right platform. Some things that need high performance are going to be best on virtual machine. Sometimes virtual machines are going to cost too much and we should go to a serverless environment. You can't have a bias. We've got to use the right resources for the right thing. The same way a doctor uses the right prescription for the right patient's condition after considering the patient's allergies and mental health statistics and other medications they take. Same thing. I learned architecture when I learned to practice internal medicine so many years ago when I was a nurse practitioner. It taught me how to think like an architect because architecture and engineering are so different. I think my MBA helped too. There was a lot of business architecture training there. And we have to design for the capacity. We need to make sure that each component in the chain will be able to get you to the goal. So finding resources, right-sizing resources, eliminating bottlenecks. These are what we're dealing with. Capacity planning. You occasionally hear people say you don't need capacity planning in the cloud because it's just auto scales. That is the most dangerous guidance I have ever heard someone say on LinkedIn. And, I'll tell you need capacity planning. Azure will tell you need capacity planning. Here's the thing. If we don't know our demand, we won't know if our systems can take it. And if we don't know our demand, we won't know which type of systems to use, which means everything has to go on demand, which means higher cost, which we don't want to do. So we want to use predictive modeling and forecasting techniques to know what we're using. Because we want to get exactly what we need without over provisioning. And every design choice we make is going to affect our performance. So we have to identify performance requirements. We have to document them. We have to estimate the compute capacity for whatever the workflows are that we need. We should then allow for auto scaling in just in case. And we can always go from auto scale to provision later when we know, but adjust auto scaling based on performance in the environment. Always great to do a proof of concept. Many of my customers want a proof of concept. I've led many proof of concepts. And when you do a proof of concept, if you're an architect, make sure you build a great engineering team. people that are there that know what to do, how to fix it, how to troubleshoot it. And when something doesn't work in the proof of concept, they need to be able to go figure out why and give you all the information that you can potentially talk to your entire architecture team about to make some redesigns on the fly. Because what works in theory doesn't always work in reality. And make no assumptions. We need to talk about achieving and maintaining a performance. So this means things are constantly ongoing. Features will be updated, which will change versions of things. Somebody updates an operating system and now it uses more compute capacity and now we need more servers. The key here is to fine tune. These technology platforms are living. So you're constantly going to be tuning them as needed for the environment. Make sure things are tested, not just proof of concept. Use performance tests. There's lots of great QA people that can use Ixias, for example, to send traffic to our network to see if it can tolerate it, see where it breaks, and really go through and make sure before you put it into production. Optimize through observability, really watch, and then scale up, scale down, add capacity, remove capacity. The key here is you really want to make sure and constantly monitor your systems. You know how you buy a PC and all of a sudden it worked great? And you notice your performance erodes over time? Well, do you need to reinstall the operating system on your PC? Maybe, because you collected a lot of junk along the way. All of a sudden, are you using new applications that are using more compute and more DRAM? Maybe you add more DRAM to your PC and it's enough. If you're hitting the page file so much, for example, or if you're on a Linux machine, if you're hitting the swap file, DRAM will help. But if you're not hitting the swap file, for example, on your PC, or your page file if it's Windows, swap file if it's Linux, maybe it's your GPU that's too slow. So what's your GPU telling you? Or wait, maybe the CPU can't handle something because something's changed. That kind of thing that you would have to do is the same thing you have to do in the cloud, but it's going to be on thousands of systems. It's the same kind of systems you would do in your data center. So it's all that. So continually monitor, optimize, test, and deploy. And use any efficiency gains you can. Any opportunity to have reduced costs, do so. And realistically speaking, set measurable, specific performance targets that you can actually see. So realistically speaking, we're talking about a lot of things. And periodically enhance your architecture. Look at new design patterns to boost performance. Interest rates go down. Well, that affects the macroeconomic environment. And what opportunities does that present for the business? And it's here. New regulation comes in. Okay, that affects the business too. What changes do they need to make in terms of their people, their processes, and technology? Because it affects all three. So really, that's what we're talking about here. Quantify success. Make sure you got a successful target with key performance indicators. And that starts from knowing what the client needs. What are you building for? And determine, sometimes you're going to find that there's a goal to build something, but it doesn't make sense to build it based upon the needs. The benefit gleaned by the business will be less than its cost. Throw that out, unless it's regulatory or required. So we're looking to make sure that everything we do has a purpose and it provides something. While we're going through these as part of the system, look at the dependencies between systems. How does this network, how does this link, how does this subnet, how does this IP addressing scheme either support or mess up the system? If I've got discontiguous subnets, I can't route summarize, for example. So look for all these things when you're going through it. And this is what you're generally trying to do. Regarding designing for resilience, expect things to break. I'm going to say it again. Expect the cloud to go down. It will happen. Expect availability zones to go down. Expect regions to go down. Expect the cloud provider to be hit with a DDoS attack and their performance to degrade. Expect lots of things to break. So game it. If this breaks, what's its impact and how can we do to protect that? Identify critical components. Analyze failures. If you got a failure, see what worked, see what didn't work, and then figure out how to not make it happen again. And this goes to anything. It can be from a router to a payment gateway, but that's really what we're talking about. Things will break. So how do you modularize your design so that one problem doesn't affect another problem? How do you constrain your network so that one area doesn't affect another one? These are the kind of things we're talking about. We've got an application where a message doesn't go from point A to point B. Do we need retry logic? Well, if so, let's do it. So this is the kind of thing we're doing. Sometimes decoupling and queues, for example, help there. And with regards to designing for recovery, well, first there's disaster preparedness, which is way outside of the Azure well-architected framework. So businesses need to evaluate their cost of downtime, what people do what, where other people are, what people need to respond in an emergency, what qualifies a disaster, who activates the disaster recovery plan, which legal people involved for the compliance purposes, who speaks to the press. All of this stuff has to be planned out. And where do you go if there's a recovery? Where do you house your people? What safety mechanisms do you have in place for the people in that business to tolerate this kind of problem? Do you need to stockpile food, water, oxygen, first aid supplies? In some cases, yes. So think about all these. What's your disaster recovery response going to be? Where's your disaster recovery data? And hopefully it's not in the same cloud. And realistically start looking to these things. So what can you do? How can you set these kinds of things up? And that's really what we're talking about. We've got a disaster recovery plan. We have to test it, right? We have to see if it works. We have to run drills like we would do in a fire drill. And when we run drills and we test these plans and we find out things that don't work, we've got to go fix it. Same thing with incident management and incident response procedures. So realistically speaking, deal what we're dealing with. Design for operations. Predict the problems that will occur. Test the problems that will occur. Simulate failures. There's not only with tools for like chaos engineering tools, but break things manually, break the network, and at least test things at the right time. Set thresholds. Now, here's something. I can always tell somebody that really is like a new architect because they have something that's incredibly complex and they show it to a senior architect and they're like, nope, it won't work. So the more simple you can make it, you've heard the term Occam's razor, or maybe you haven't. The simplest solution is usually the best. Really try to make these solutions simple. Simple reduces inefficiencies. It enables support. It reduces potential misconfigurations. But don't oversimplify to the point where you create single points of failure. So do what you need, get it to where you're at, standardize the software development lifecycle, standardize your software, your information things. When it comes to security, understand that secured security model, understanding your security readiness plan with business priorities well-defined, where your investments are, your accountability. Make sure your systems are scoped. Use a combination of zero trust and defense in depth because neither one is good enough on their own. Protect that confidentiality, integrity, and availability of your systems. Really look for the kind of constraints that you potentially have along the chain. Really do anything you can to segment your systems. So, in the data center, we've got a lot of segmentation. In the cloud, we have very minimal segmentation that we can actually do, but maybe you can segment on, subnets. Maybe you segment your systems in multiple VNets, and by doing so, you get more secure. The question is now you have to pay for inter-VLAN routing, which is another cost to try to get your security back to what you had in the cloud, but sometimes we need it. There's organizations that have 1,000 VPCs or 1,000 VNets, and they need all kinds of hierarchical routing to make that work because they need security. It's not uncommon. But you don't want to know what that costs. But it depends. If the cost of downtime or the cost of an information or intellectual property is worth enough, then it may make sense. You can segment your systems based upon business requirements, component criticality, privacy concerns, who needs to talk to whom, that sort of thing. Now, if and when you find an incident, you want to respond to that very fast. The faster you catch an incident, the less damage that gets done. So you have to have good plans, good incident response plans that your security architects will help create. Who does what, who does when, who notifies who, which people come in, who talks to whom, all of that needs to be planned. That's why architecture takes so long. And your data Data should be classified by user, usage, configuration, compliance, intellectual property, whatever is right for that business. Make sure there's good access controls on that data. And I don't just mean IAM. I mean, which subnets can get access to the data? Is things certain firewall it off? Severity level and confidentiality of the data. Does that data need to stay in this country? Can that data be shared across regions? All of that. Think about it. Maintain an audit trail so you can see what's going on, where it's going on, how it's going on, and why it's going on. Prevent tampering of your data. Implement controls in your business logic. Figure out what you can do to lock it down. If there's a supply chain, really look for vulnerabilities in the supply chain. Use cryptography anytime you can to make sure you can identify endpoints and establish trust and verify systems integrity. And back up. Now, if you back up, make sure your backups are encrypted, because if all that somebody has to do is steal your backups, and they've got access to your data. Now, again, with security, you have to balance it. If you put in too much security, you'll ultimately block the people from doing their jobs. If you don't have enough security, you get hacked. If you put in too much security in the wrong places, you'll kill your availability. If you don't put in the right level amount of security, you'll get hacked, and that'll bring down your systems and kill your availability. So, reduce attack surfaces by protecting against vulnerabilities and application codes. Lock it down on the network side. You can do less on the cloud than the data center, but you still got a lot you can do. Use good identity systems. Use good host-based defenses. Lock your systems down. Anti-malware, the host-based IDS, IPS, firewalls, all that kind of stuff. And come up with a good, strong recovery strategy. So, realistically speaking, and constantly try to get better. Always enhance your security. Always look for ways to make it better. And, perform some threat modeling to figure out where your potential threats are. Make sure your team is doing their vulnerability scans to find out what vulnerability scans are on your system, and get current and stay current. Now, let's talk about passing the exams. The Azure exams will test your knowledge of the Azure materials. They cover a wide variety of areas. And, think about that. So here's my recommendation for you. Heavily review all Azure documentation. I'd probably go through this material a second time and potentially even a third time. But read the Azure documentation. It covers the services officially, and it covers it the way they want you to know it for the exam. I also am a fan of practice tests. Now, why do I like practice tests? Because you never know the way somebody's going to ask questions. I ask questions in a very clear manner. But some certifications are asked very clearly. And if you're dealing with a really hard certification, they're going to be very clear about the requirements, and they're going to make sure that you have the knowledge to be able to answer it. For example, if I was dealing with an exam like a CCIE or a CCDE, I might make a question that might say, please make sure that you don't have any type 5 LSAs in this area, but you will need to redistribute an EIGRP route into this area. I might also say that this interface should not be able to form an adjacency with something else. And that tells me that I need a not so stubby area, and it tells me that I need a passive interface on OSPF. Now, it's very simple what I said and very straightforward, but you have to have good knowledge to actually understand it. By comparison, this is these are multiple choice exams. So in a multiple choice exam, I don't have the ability to really test your knowledge or competency very well, like in that example I just gave you. I have to basically give you things that are going to sound complicated and sound distracted and act very worry, and test you in little minutia that in the grand scheme of things is not that important. But it's the only way I can do it. So the way questions get asked are very wacky. So if you take a practice test, you're going to get used to the way these people ask questions. And the best way to use a practice test is not just to memorize questions and answers. You should go through the test. They ask you a question. Before you even look at the answers, I want you to think if you could answer it cold. Because if you can, then you're good. Then when you go through the questions, I want you to look at it and say, okay, this is right because this does this, this does this, this does this, this does this. This is wrong because of this reason and this reason. And then anything that you weren't sure about, I want you to look it up. Go back to the Azure site and look at it. And that way, a 60 question exam might take you 5 hours or 6 hours or 7 hours to go through it, maybe 8 hours, but you're going to learn something. And then keep at this practice exam until you can score a 95 or better consistently, and then go take your exam, and you'll most likely pass. That's how I've always passed my exams. Now, because these exams are wordy, and because these exams are lengthy, and you're going to have to think about the words, and it's going to be the minutia, don't go tired. Get a good night's sleep the day before. That's not the night to go out there and eat a large pizza and eat some chicken wings and drink a pint of beer, where you're going to be up all night and feel like garbage. So eat something that's going to be good on your body. Avoid alcohol that night before. Don't go out there and take some substance that's going to make you waking up feeling foggy the next day, because it'll impair your thinking and judgment. Now, I'll give you a little psychology pretty quickly. So when we're relaxed, we use the prefrontal cortex part of our brain. This is where all your logical reasoning is. This is where your good thinking is. This is where you say polite things. When we get stressed, our prefrontal cortex is the good part, thinking part of our brain. They shut down, and the amygdala kicks in our brain. And the amygdala is great if I got to go block a knife attack like that. It's great. But it's not great if I have to do some thinking. So because of that, be relaxed. And what I mean by that is show up 30 minutes for your exam. Because if you got to the exam and you're working really, really hard to get there on time because you got stuck in traffic, and you get there and you're all sweaty and your heart's doing this before you get there because you ran up the stairs because the elevator was broken, prefrontal cortex shut down, amygdala kicked in, and you're not good. I'll tell you, even when I had no money when I was a kid, if I had an exam, I found the nice, comfortable parking lot where it was safe if I had to get there. I parked in the car. I got there an hour early. I had a nice drink of like a water or a green tea, something that I would feel good. And then I'd mosey up along there and I would be relaxed. So at minimum, get there 30 minutes early. Even if you take the exam remotely from your home, 30 minutes early, because sometimes your computer will crash. Their systems will not be good. So please do that. And I hope that kind of helps. So do that. And bring your ID. And maybe while you're at it, you can choose my high availability knowledge. 1 is none, 2 is 1, and 3 is greater than 2. Maybe bring 2 or 3 forms of ID. I always have my driver's license with me, and I typically bring a passport with me as well. And if that way they say, I don't like your driver's license for whatever reason, or I lost my driver's license, I got a backup. So hope that kind of helps. So I'm going to open it up for some questions. This concludes our discussion of our 2-week completely free Azure Solutions Architect Expert Bootcamp. Week 1, where we really talked about cloud computing. Week 2, where we really tried to focus on honing in on that certification exam. Any questions, let me know. And if you can, hit the like button, subscribe, hit the bell. So is migrating a legacy application a significant challenge for developers or architects? Well, it all depends on what's involved in it. So, the application developers are doing the work. So realistically speaking, it's a good question. So if I was going to migrate an application and I'm leading my architecture team, and I'm the enterprise architect or the cloud architect, I have to focus on everything. An application is one of a million components. I got to deal with the network. I have to deal with the security. I have to deal with the AI. I have to deal with the IAM. And note, I said IAM outside of security. There's a reason for it. I have to deal with any machine learning that's going to be used for data analysis. There's so much that I need to deal with the applications. So what I'm going to do as an architect, like a cloud architect, is I'm going to have application developers on my team, and I'm also going to have an application architect. I'm going to meet with that client and discuss their applications, and I'm going to be me and I'm going to get the business requirements, and I may bring the application architect to go ask various questions on that application. I will work with that application architect to design an application migration plan, and the developers will actually do everything that's necessary for there. Is migrating a legacy application a challenge? Yeah, sometimes. Sometimes it's absolutely nothing. Moving it over to as a virtual machine to the cloud is absolutely nothing. Now, Preb, I've worked on where I migrated applications where it was developed by someone that committed suicide that wrote absolutely no documentation on it. And that means really hard because, that's pretty hard to figure it out, especially when the source code wasn't available, only the compiled code. That is an absolute nightmare. Other times, you've got something, it's well documented, that people have good information on it, and it's simple. So it all depends. But generally speaking, nothing is easy when it comes to migrating anything because there's so many moving parts that are involved. And that's why it's not like a certification. That's why it's so many teams, because when you actually look at these applications, many of them have things related to business logic. And it could be right for the business or wrong for the business. And it can be there. So it can be great or it can be horrible. It can be complex, it can be simple. It all depends on what you're dealing with, which is a great question. See, Rainey, I love to share knowledge. I'm happy to share exam tips. Thank you for joining us. Lonzo, I love those. I think they're balloons or party things. I'm totally good with it. Send me a WhatsApp message and actually explain them to me, but they look nice and happy, and I love happy things. Cantor Grant, thank you so much, Mike and team, for this boot camp. You're so grateful. Cantor, thank you for joining us. And thank you to my team. My team worked very hard behind the scenes to put this together. We had Alonzo do a whole lot of work to try and pretty it up and give me some slides that I can share, because people that know me know I make slides that says, Mike, talk about BGP, talk about it being TCP, talk about the messages that are involved, talk about the finite state machine. So things where I thought it would help, Alonzo did a lot of graphics back in the scenes. Have I had to design architectures for companies that use ERP like SAP Oracle? I've never had a company that didn't have an ERP, that didn't have a CRM, that didn't have a wide variety of enterprise applications, potentially hundreds, if not thousands of them. The ERP would be the smallest, most minimal component of the entire thing. That's the easy stuff. It's the everything, the network, the security, the data center, the ERP. Valerie, it's always good to see you. Thanks, Mike and GCT, for all you do to train well-rounded tech professionals. Have a restful weekend. Thank you, Valerie. My wife is in Philadelphia right now, so I have a big plan to hang out with my cat, Cindy. I've got her 12 bags of cat lollipops that are tuna lollipops and chicken lollipops. And, I have lots of plans with me and my cat. I would prefer my wife being home, but I love my cat, Cindy. Prab, thank you so much, Mike and team. It was so nice to see you here. See you in class as well. Renato, always good to see your name pop up. Thanks a lot, Mike, for your magnificent generosity, especially for this free course. Happy weekend, everyone. Happy weekend, everyone. And Renato. Adrian, thank you so much. Dennis Bell, my student, you just passed the Azure AZ305 certification. I am so happy for you. Ibuka, you are more than welcome. Thanks so much to the entire team. Yes, thank you to the team. I'm so happy about you passing this exam, Dennis. And thank you so much, Phil. Dennis, the next time I see you, we need a Red Stripe beer together. I don't drink a lot, but I do like my Red Stripe beer. Manny, thank you, Mike and the Go Cloud family. This training was great and very awesome. I'm so thankful you were here. Foolish the Crow, great training. Thank you so much. Have a wonderful weekend, everyone. I hope you had a good time. Oh, Leonard, always good to see you. We will have lots more videos coming to